Shaddai Adonai. Father, we say we thank you, we bless your name. We worship you and we give you all the glory. Start with us, continue and finish with that. In Jesus' name we pray. And let the saints say amen.
Amen. Many thanks, Apostle Dr. Ophelia Meffo. Give her a better round of applause. All right, before we continue, I shall humbly invite Madame Irabna Gloria Okra to join us at the high table. She is a member of the National Board of the Itfp. Ladies and gentlemen, let me quickly introduce to you the gentleman at the high table. So I have already mentioned Madame Irabna Gloria Okra, who is a member of our national board. Seated next to her is Professor Ebenezer Boakye, the Pro-Vice Chancellor-elect of the Takoradi Technical University. The man in the smock is a deputy registrar at the School of Graduate Studies. This morning he sits in the stead of the registrar of the university. His name is Nana Oti Boateng. He's a chief. The man in the middle is a big man. Some of the things, if I say it, I'll go to this Mary board. He's the overlord of the Takoradi Technical University, the Reverend Professor John Frankeshen. He is a consummate professional, a consummate researcher, and administrator. Now, things like this intrigue him. He enjoys sessions like this. So I am very, very happy he's here. Barely a few minutes ago, we were told a big program was taking him out of the jurisdiction. We were just distraught. Then in like 2 minutes, we received a call that no, he will come back. He says he's coming. And all of us were celebrating outside. So VC, we are very, very grateful. In the last 2 weeks, he has been out of town. We knew he was in South Africa. We didn't know he could make it. So we are very grateful, VC. Thank you so much for making it here. Without further ado, I shall invite our national president to address us. He's in the person of Professor Richard Itfp-Gh. They don't know the Itfp-Gh.
It's not official.
Oh, I see. I see.
Itfp-Gh is not official. Thank you very much. Prof. Chair, Reverend John Frankeshen, Pro-Vice Chancellor, Professor Boakye. If you saw my poster on the platform for contesting for the provisorship, this is the gentleman that beat me. He's accordingly good. It was battle of wits anyway, and anybody could have been superb. And Prof, you're welcome. And acting registrar Nana Boateng, Madam Irabna Okra, board member, distinguished guests, I welcome you to Takoradi Technical University. Well, ITFP is a professional network of textiles and everybody involved in textiles, fashion, garments, and allied areas. And it's been around for the past 10 years, except that the progress has been very, very slow. But some way, somehow, we've come this far. I've got a long speech here, but because we have to join online in about the next 15 minutes, I would refer you to the speech in the brochure. And I would officially welcome you all to TTU so that the chair can give a very resounding address. Then from there, we'll just zoom straight to our people who are online in the UK to take over. So you can address yourself with the speech on page 7 of the brochure. On that note, I welcome all of you to TTU. Have the best of time whilst you are here. Prof. Chair, I can say that we have over 85 papers submitted from several countries. Of course, the MC will mention some of the countries that are, and we are going to have a lot of presentation coming online and also in person. So, members, you are welcome. Thank you very much.
Oh, a round of applause for him, please. So our chair for this august function, as I said, is a consummate professional and researcher. I cannot count the number of researches he has undertaken and articles he has written in peer-reviewed journals. But certainly he's intrigued by sessions like this, and he has clearly demonstrated it, having to cut short his trip to South Africa and come back here to join us. He actually thought it was yesterday. And so someone overheard him talking about it at the airport and quickly called us. And so we had to quickly inform Auntie Julie, the Executive Secretary, Dr. Juliana Abrokwa, that it was actually today. So ladies and gentlemen, our chair for this function is the longest serving Vice Chancellor in any technical university in Ghana. To be able to do that, you need to be a very hard-working person. Yes. Longest serving and still very popular. The Reverend Professor John Frankeshen is our chair for this august function. So we shall receive his address.
Thank you, MC. Professor Richard Akwe, the National President, ITFP Ghana. Distinguished members of the ITFP Ghana Board, the National Executive Committee of the ITFP Ghana, Professor Dr. Hughes Riley, ASU Prof, Nottingham Trent University, United Kingdom. I have a lot of tall lists here. Members of TTU management, directors, dean, heads of departments and units of the Takoradi University, ladies and gentlemen, esteemed colleagues, distinguished guests, and conference delegates. It is with great honor and a profound sense of purpose that I welcome you to the second International Research Conference of the Institute of Textiles and Fashion Professionals, Ghana, graciously hosted by Takoradi University. This important gathering stands as a testament to the collective commitment of academic professionals and scientific researchers dedicated to advancing the frontiers of knowledge within the realms of the textiles and fashion industry. The textile and fashion industry holds a pivotal place in the global economy, serving as a powerful expression of cultural identity. It is an industry that not only fosters economic growth, employment, and innovation, but also serves as a vital conduit for cultural expression and societal development. Its profound influence extends beyond artistic to encompass sustainability, ethics, and environmental stewardship. As you convene today, it is imperative to recognize that the industry bears both the privilege and the responsibility of shaping a sustainable future, one where creativity meets diligence. The overarching theme of this conference, Innovating for Sustainable Future, Advancing Technology, Circularity, Design, and Education in Textile and Fashion, underscores the crucial importance of integrating sustainability into every facet of this industry. In an era characterized by rapid technological advancement, the challenge lies in harnessing this innovation to develop sustainable solutions that are both economical, viable, and environmentally responsible. As experts and practitioners, you are called upon to critically examine existing practice, challenge the paradigms, and pioneer novel solutions that reconcile economic viability with ecological integrity. In particular, the pursuit of circularity, which is creating closed-loop system where waste is minimized and materials are continuously reused, must be central to your effort. Innovation in textile technology can enable the development of biodegradable fibers, eco-efficient production methods, and regenerative material that reduce the industry's environmental footprint. Furthermore, progressive design strategy that focus on longevity, versatility, and reconcilability can reshape how consumers engage with products and encourage sustainable consumption. Equally vital is the role of education in nurturing a new generation of industry leaders who are not only skilled in cutting-edge technology, but also deeply committed to ethical and sustainable practices. By embedding principles of sustainability, circularity, and responsible innovation into our curricula and professional development program, we can cultivate a workforce equipped to lead transformative change. I wish to extend my heartfelt congratulations to the Institute of Textile and Fashion Professionals for their steadfast dedication to promoting excellence, innovation, and scholarly discourse within this vital sector. Your commitment does not only elevate the standards of educational and scientific endeavor, but also propel Ghana and the borders global community towards a more sustainable and responsible textile and fashion industry. To the participants and presenters, I urge you to use this platform to think beyond conventional boundaries, seek to engage in deep, critical, and transformative brainstorming that will generate novel ideas capable of redefining industry norms. It is essential that we challenge ourselves to develop innovative solutions that address pressing environmental concerns, promote circular economies, and ensure social fairness. Your collective creativity and scientific rigor can serve as catalysts for change, thus breaking barriers and rewriting the narrative surrounding sustainability in textile and fashion industry. As I conclude, I encourage all delegates to seize this opportunity to network, exchange knowledge, and create partnership that will drive meaningful progress. You should come together and commit to shaping an industry that is not only economically prosperous, but also environmentally responsible and socially equitable. Through shared effort, you can build a future where the textile and the fashion industry continue to inspire, innovate, and uphold its vital role in global development. I sincerely thank you all and wish you a conference filled with fruitful discussion, groundbreaking ideas, and lasting collaborations, as I proudly accept the honor of chairing this memorable event. God bless us all.
Oh, you can do it better. So many thanks, VC, for that exhilarating speech, which is a clarion call to break barriers and help change the narrative in the area of sustainability. Thank you so much, Prof. We shall do just that. So, Prof, I think on that note, you would have to formally launch the conference, marking the formal opening.
I formally open the second International Research Conference of the Institute of Textiles and Fashion Professional, Ghana. Thank you.
Thank you so much, Prof. So conference is formally opened. Let me introduce to you another management member of the university, our acting librarian, Papa Kwame Nafin. Our Director of Public Affairs and Executive Secretary to the Vice Chancellors of Technical Universities Ghana, Mr. Joseph Oti Esrifi Mensah. Thank you so much. He's been very, very instrumental in publicizing the program. He was in South Africa with the Vice Chancellor, but he was still posting. Thank you so much. ITFP is grateful, Mr. Oti. If I haven't introduced someone, it isn't deliberate. As and when I'm prompted, I'll do so. Thank you very much. So we are live on YouTube, and we have presenters from across the world, from Bangladesh, of course, our host nation, Ghana, Hong Kong, India, Nigeria, Rwanda, South Africa, United Kingdom, United States of America, and Zimbabwe. I didn't hear you clap. So this is truly international. Next on our program is just a minute. Give me some musical interlude there while I the oracle. Regional reps of Itfp-Gh, if you could rise for us to acknowledge you. Western region. Okay, let me go according to region so that. Okay, so Western region. Dr. Moses Akrofi. Central Region. Oh, Central Region, our rep is the Dean of Students of CCTU. Yes, thank you so much. From Central Region, we are going to Greater Accra Region. Accra. Okay, I'm told Accra is outside. Volta Region. Oh, the team is led by Divine Vigbedo. Dr. Divine Vigbedo. My friend. So from Volta Region, we are going to OT Region. Volta and OT, okay. That is fine. And then it means that Northern Region 2 is 1. Is it? Okay, Northern and Savannah. Northern and Savannah. Okay. Ashanti Region. Oh, Professor Asenyo, thank you. Thank you so much for making it. Eastern Region. Eastern Region. Okay, Bono. Okay. Are you representing the entire Bono area or just? Oh, that is big. Give him a round of applause. It means that the Ashanti region and Northern region are doing a great job. Northern and Savannah. Give them a round of applause, please. It's big. All right, so let me also introduce our national executives. So, Professor Richard Nikpakpo Akwe is our national president, yeah? Just a minute, give me a... Just a minute. Okay. And then national vice president is Professor Ebenezer Kofi Howard, KNUST. Our national secretary is Dr. Ninette Afi Apia, Amusted, Akenteng Apia Menka University of what? Of skills, technology, entrepreneurship, development, or what? Ewarof. Give them a round of applause. Amusted. You are? Amstead. Oh, okay. So it's just like a hunterman and a huntsman. Oh, okay. Then we have Dr. Solomon Mafo Ayesu, National Treasurer, Kumasi Technical University. Kumasi. Theirs too is KS, K with a small T, a small S. KSTU. KSTU. A round of applause for him, please. All right. And then we have our board, the national board, which is chaired by the vintage Professor Charles Frimpong. He couldn't make it because of an equally important national assignment. And that is why Madame Irabna Okra is standing in his stead at the high table. But we can clap for him in absentia. Then Dr. Daniel Kwabna Danso, board secretary. Is he here? Could not make it. Professor Richard N.K. Akwe. It says it's not official, but when you go to Facebook, you see RNK Akwe. Do you know the meaning? Richard Nick Pakpo Akwe. That's the meaning. Then, also on the board is Professor Ebenezer Kofi Howard. Dr. Ninette Afi-Apia. Dr. Solomon Ayesu Mafo. Reverend Timothy Crensel, a.k.a. Taimo. A round of applause for him, please. Jerome Kweku Dunyo, also a board member. And he is at Volta Star Textiles Limited. Of course, Madame Irabna Gloria Okra. And then Mr. Kojoe Jenim Boateng, he is presently head of production, right? General manager of TSG, Textiles Ghana Limited, owners of the GTP brand. So we are big in the area of textiles and fashion. I didn't hear you clap. Okay. We also have here, gracing the occasion, the director for the Center for Gender, Disability and Advocacy, Dr. Mrs. Bertha Danso. Yeah. Thank you for coming, co-pilot. Thank you for coming. So I guess we can. So we shall invite our first keynote speaker, Dr. Hughes Riley, Associate Professor, Nottingham Trent University, United Kingdom, and he is going to speak on advancement in electronic textiles in the era of sustainability. He is joining us online.
I'm not able to share my slides at the moment, unfortunately.
Hi, Thea. I'm here in the room and I can hear you, so you're not with the voice.
Thank you.
I tried earlier as well. I think you need to do request sharing. So if you sent a request,
Let's see what that is actually.
So if you click down on share, there's send request.
Oh, I'm able to share now. Thank you.
Okay, great.
Can everybody see my slides?
Yes, I can see them again now.
Yes, I can see it from here.
Okay, thank you very much. Well, thank you very much for the introduction and for inviting me to speak at your conference. Today I'm going to discuss advancements in electronic textiles in the area of sustainability. I'm mostly going to focus on two areas. One is the electronic textile developments that we have been making at Nottingham Trent University with a focus on electronic yarn technology, which is a means of integrating small-scale electronics at a yarn level and then making those into textiles. I'm then going to talk about a framework that we've developed for evaluating the sustainability of e-textiles and essentially show how we've been able to take that and applied it to our own e-textiles to create more sustainable products. As I'm the first talk today, I realise there are a few others on smart and intelligent textiles later, but I'll briefly introduce the concept of e-textiles for those of you that are less familiar. But essentially, electronics can be integrated into textiles in a number of different ways. Broadly speaking, there are sort of three methods. One is to take a pre-made textile and to attach the electronics somehow. This is the oldest method that's been used and the most common in products. So things like textile heaters, for example, use this kind of technology for the most part. This can be quite varied, so it can go for anything from just sticking a device onto something to printing, embroidery, etc. There's then structurally integrated electronics where during the knitting or weaving process, you'll take a conductive material as one of the textile construction elements and integrate the electronics that way. We do some work in this, particularly with knitted electrodes for a variety of applications. And this can create textiles with quite normal look and feel. And then finally, there are innovations in the area of yarn integrated electronics. So either by creating functional yarns by layering materials or by embedding small devices into yarn and fiber-like structures. And this is what I'm going to talk about today. And this is sort of like the bulk of the research that I conduct at Nottingham Trent. So I'll briefly explain how we create these devices. So we start by taking an electronic chip of some description. I've got two examples here. One represents something like a temperature sensor, and one represents a slightly more complex component like a motion sensor. And we'll take this and we'll solder this onto Litz wire. So this is a multi-strand wire, but it's very, very thin, and it's not quite like a normal textile yarn, but it's pretty similar in terms of its deformability. By soldering this, we can create electrical connections, and it also creates a mechanical connection to the wires. Obviously, any textile we create, we want to be durable. So we'll then encapsulate this component along with the solder joints within a very, very small resin micropod. To give an idea of scale, a normal component micropod would be maybe 1.5 millimeters or so across. This is a hard pod, but as it's so small, you don't feel it once it's integrated into the garment properly. At this stage, we also include supporting yarns. This essentially adds additional strength, but it also bulks out the final structure, so it's more uniform. We finally cover the ensemble with the textile sheath of some description. So we typically use a braiding machine to do this now. And as you can see, two images of what these final yarns will look like once they're covered. This adds additional strength, but it also consolidates the package for integration into a textile properly. So there are three main methods that we typically use for integrating these. Some of these are, in fact, appending the electronic textile to a regular textile afterwards. So we can use the coaching technique. So we'll have a pre-made fabric, we'll lay the yarn down and then stitch over it. We can use it as a weft yarn during weaving. And then we can also integrate it during knitting. So we can lay it in during the knitting process. However, what we typically do is we create a knitted channel and then insert it afterwards. And when I discuss the sustainability aspects of the technology a bit more later in my presentation, you'll understand why we typically go with this technique. So most of the examples I'm about to show, the integration has been done in this way. This creates textiles with very normal properties. So this is just a panel with some LEDs, but you can see that the panel can be fully deformed, stretched, etc. The yarns themselves aren't stretchable. So we have made a version that's stretchable, but they're typically not stretchable. But we typically introduce stretch through the intrinsic properties of the knit. Obviously, textiles that people are going to wear need to be comfortable. A lot of what we look at is for health, well-being, sports, and personal protective applications. And three of the main factors affecting comfort for those are the air permeability, the thermal conductivity, and the water absorbance. So we have a full testing lab, and we tested our textiles against using standard testing equipment. to understand how the integration of the components affects those key textile properties. And as you can see here, compared to a standard knitted structure, so we're testing essentially the same base structure, the introduction of the components makes very little difference to the properties of the final textile, which is great because that will obviously then mean that it's comfortable for the end user. We have also tried to test drape. Unfortunately, standard drape testers aren't very good for e-textiles. This was an outcome of a piece of work we did a while ago, and we are looking at how it is better to test drape with e-textile products. And this is largely due to the fact that the electronics are normally in quite a discrete area, and drape testers are designed for more uniform textile structures. These yarns are also wash durable. So we've done some quite extensive wash durability studies with the materials. This is a picture from a recent set of wash tests that we did. We've used standards for domestic laundering, and we looked at 25 wash cycles. One other factor that we did explore was how the size of the micropod, so this resin pod within the yarn, might affect wash durability. And that's because with an older design of electronic yarn, we realized that there was a trend that larger pods led to greater failures. So we wanted to fully re-examine that to understand if there was any trend there. This is just some example data from the wash test. So it's just from five components of the 90 that we tested. So after each wash, we would test the resistance of the component to see if there was any notable change. Really, we found that there wouldn't be changes. And if a component stopped working, you would just see because there would be no more conductivity. So it wasn't like there was a deterioration over time. It was simply, it was fine and then it was broken. However, overall, we saw very, very few failures. Of the 90 samples, 7 failed. There wasn't really a clear trend in how integration affected durability. So we looked at woven, embroidered, and knit integrated yarns. We looked at different sizes. The really key fact So I thought for this presentation, I would give you an example of using the framework. So we did another teardown of a different product just to go through how we use this. This was a heating pad that, this is post-consumer. It was, I actually got it from my boss, he didn't want it anymore. Here's a photo of the pad. Something that's important to highlight here is that we were not able to locate the product online. We found something that looked very similar, but we don't think it's the same product. And this highlights an important thing about these products, which is perpetual information about the product and its makeup is really important for post-consumer disposal. The product label did show that it is washable, and it did give proper care instructions on the label, which is really important. Actually, the fact that it's washable is extremely important for the product to be maintained, particularly as it's not technically a wearable. It does say that it's recyclable, and it does have the Waste Electrical and Electronic Equipment Directive symbol on it, so it should be recycled technically. Quite what would happen to it if it went to a recycling plant is unclear, as again there's a need for education about how to address these kind of products. So we disassembled the product, we tore it down to understand its constituent components. This was quite a simple product. So there were 2 outer fleece layers, felt layers inside, and then there was an electric heater, which was a printed electric heater. The product that we found online, actually, that we didn't think was this, while it looked identical, it explicitly said that it was a graphene printer, a graphene heater, and we're pretty certain that this is printed silver. However, again, this shows the importance of having information, again, having traceable information so you can understand what the product's made of. I will actually say, and this comes up on my next slide, the product specific said there was 100% polyester on the label, which, I mean, you can see here, it clearly, maybe the textile is, but clearly the product itself is not 100% polyester. So from this, we created an interaction matrix looking at how each component interacts with one another and to understand possible pain points, as well as other areas which may be improved. So the heated printer is probably the largest point of concern. That will probably have to be disposed of landfill, certainly without further information. There's not much you can do with that. There are things, for example, like the polyester, that could be replaced with a more sustainable fiber. However, it's not, polyester can be recycled. Some things like the USB connector can be reused. A point of it, an issue, and this is something that we've noticed with pretty much every product that we've torn down, is the use of adhesive. Now, I would say this product was actually quite good in so much that it mostly used stitches to hold the product together. However, there was some adhesive, and obviously getting the adhesive off is a bit of a pain. With some products, it would pretty much make recycling impossible, however, not in this case. We then applied this knowledge to the sustainability qualities framework, so understanding points where improvement could be made. I would say in particular, there were some difficult to recycle materials that would need improvement in this case, and again, as I said, to minimize adhesives. So this gives you an idea of sort of how the framework works. We have applied this to our own products. So one example I'll show is a temperature sensing sock. So like with the vest, this was for measuring skin temperature. We originally developed this for the military as they wanted to understand non-freezing cold injury. So damage to the skin that happens in above freezing conditions. This is a particular problem in Wales, I think. The technology, of course, could also be useful for monitoring in some sports such as mountaineering, where again, things like non-freezing cold injury could be an issue. And of course, we have applied this core technology to other things afterwards. As this was one of the as temperature-sensing socks was one of the earlier textiles that we developed, this has gone through many iterations. So this is an earlier iteration of the sock to what we currently have. There were some design features already incorporated specifically to address end of life. So you can probably just about see the channels on the bottom for placing the components. So we had created socks using laying in for the yarns, but we later realized that for both end of life disposal, but also for repair, it's much better to use a knitted channel, as you can remove individual yarns and replace them. Whereas if you integrate them using laying in, if one of the yarns breaks, then the sock needs to be disposed of. In principle, the yarn should outlive the sock. And part of why we worked so hard on improving durability is to improve lifetime. So ideally, you would be able to, at end of life, strip the sock from the yarns and then reuse the yarns in another product. So we tore down the sock to conduct an analysis, and you'll see a lot of the images are actually of the supporting electronics here. When looking at the interaction matrix, a core issue was identified at being the electronics module itself, although there are other points of potential improvement, such as the materials which are used, including the UV curable resin, but also the use of polyester elastomerics. However, we have struggled to replace those at this time. As you can see from the sustainability framework, there's key points include minimizing consumption. So a major issue, and this was to do with the module, however. So this module was silicon encased in silicon, and we did this to make it softer. However, a massive problem with this would be that if you wanted to repair the module, it was extremely difficult. So the battery was also in this module, and obviously batteries are known to wear out over time. So from this, we realized that the case needed to be improved so it would allow for easier repairability and replacement. The design on the left was the design that immediately came out from this study. However, we are always innovating and improving, and the design on the right shows what the module currently looks like. So this module is about the size of a matchbox now. So it's very easy to remove the electronics if necessary for repair. And in fact, we've had to do this on occasion. As I mentioned earlier, this framework should be applied in an iterative way as prototypes being developed. And we are aware that we could maybe improve some material choices for some of the yarns, and that's something we will look at. Ease of repair is also a very key thing. So I think I'm almost out of time now. But just to summarize, I've discussed different methods for creating electronic textiles using, and the use of e-yarns has been discussed, including showing different things that we've developed using e-yarns. I've introduced a new textile sustainability framework, and also shown how we've applied this to our own prototypes to improve the sustainability of those. I'd like to acknowledge some of my key contributors to this work. Obviously, most of what I showed you was from the literature, but these are people either in our lab or who have been long-time collaborators. Also acknowledge people who have funded some of the research over the years. And for those that are interested, here is some further reading. Our website, eyarns.com, has lots of stuff on it, so links to most of these are available there. Thank you very much for your attention. I'd be happy to take questions.
Professor Theo Hughes, we are very, very grateful, very insightful. The advancements are incredibly staggering. Give him a round of applause. You've done so well.
Thank you.
Now, before we take the next keynote speaker, the Vice Chancellor will bow out. As I told you, he has a very important assignment to attend to. In his stead, the Pro-Vice Chancellor-elect shall sit. Ladies and gentlemen, shall we rise as the Vice Chancellor leaves us? Thank you very much. Shall we resume our seats, please? Now, before we take our next keynote speaker, we'll do Q&A, but we would like to take the second speaker first before we do the Q&A sessions. It is also imperative to bring to your attention that Professor Frimpong, our National Board Chair, is online, and he will give us a brief address after the second keynote speaker addresses us. Ladies and gentlemen, let me also quickly introduce to you the Dean of the Faculty of Business Studies of the Takoradi Technical University, Professor Mrs. Abigail Gura. Yeah, she's a fashionista. Yeah, thank you so much for coming. We are grateful. We are very grateful. So we shall take the next keynote, which is entitled A Sustainable Future for the Fashion and Textile Sector. And this shall be done by Professor Claire Lepinier from the De Montfort University in the United Kingdom.
Right. So hello everybody, I'm Professor Claire Lepinier. I'm a Professor of Sustainable Textiles at De Montfort University in Leicester. And I'm so pleased to have this opportunity to showcase some of what I would deem the main drivers in a sustainable future for the fashion textile sector. And it's been really fascinating to see the conference agenda and all the speakers, and also obviously all the delegates and participants. It's always so heartening to see so many people engaged in this debate and engaged in this this drive forward. So it's wonderful to be here today. So in particular, I'm going to present some recent research on sustainability that we've been undertaking at De Montfort, and work that we've done on knowledge exchange and external policy and sector development engagement work, particularly around manufacturing, working with manufacturing stakeholders, and within the global sustainability sphere. So I'm going to look at some of the drivers and values required for the transition to the sustainable future. And particularly, obviously, we're looking at that in the context of the circular economy and the role of innovation, collaboration, and networks for making this vision happen. I'll just go back a second, actually. De Montfort's history as is very much as a civic university, as a technical university. It began in Leicester as a training and employment hub for the local industry. So our local textiles industries are very embedded within the Leicester community. We have footwear, contour fashion, hosiery, socks, knitwear, and textiles. We're very kind of key to where the university began as a kind of gateway for opportunity. Excuse me. The United Nations have chosen De Montfort University to lead a network aiming to build better cities and communities across the world. So we're the only UK university to be asked to become a hub chair by the United Nations Academic Impact, the UNAI initiative. And what we do within that is we are a hub for SDG 11 sustainable cities and communities. And within that, I work with the director and other very interested members on sustainable development in as an SDG Hub Fellow for SDG 12, so responsible consumption and production. And everything I do in terms of my teaching, my research, my enterprise work is really kind of grounded in that drive towards sustainability and fairness within the textiles economy. I'm a member of the Textiles Engineering and Materials Research Group. We have a wide range of knowledge and expertise, particularly around developing innovative and technically driven solutions to some of the difficulties in textile production and textile manufacturing. Our interdisciplinary group is led by Professor Jinsong Shen, who's a textile engineer and biochemist. We do a lot of biochemistry work. With Dr. Edward Smith, who's a textile chemist specializing particularly in bast fibers, so those stem fibers and coloration. Dr. Angela Davies, who's a garment technology specialist, an associate professor in garment technology and textile technology. And we're currently really pivoting towards both biodegradation and textile recycling for natural fibers are our two kind of main areas of work. So within that, we really contribute to working with industry, working with trade bodies, bodies such as Innovating and other research and innovation funding councils to explore technological breakthroughs, which we can share with industry for accelerating the move towards the circular economy. There's a recent project which Professor Shen led on. This was a collaborative project with De Montfort University, Loughborough University, Fox Brothers, the Walmart Company, and Chimera Fabrics. You'll see a theme running through this is particularly around natural fibers. We're doing a lot of work on wool at the moment. And this is a really interesting use of enzymes for valuable resource recovery from wool blended fabrics. So obviously, there's a real difficulty in the circular economy with recycling mixed fibers. So where you have a wool blended with a polypropylene or with a polyester, or wool, which protein fiber blended with a flax or a hemp. So it's exploring how enzymes can be used in order to recycle that. So what they were working with on this project, and it's really kind of highlights the approaches that we take, where we try and work with partners across different academic institutions, but also with industry and not-for-profit trade bodies funded by UKRI funding councils. So taking low value or waste wool materials, in this case, upholstery fabrics, using enzymes and biotechnologies to extract the polypeptides and regenerate protein materials, and then also recover the flax fibers, which can be reprocessed. And that has if we think in terms of a systems thinking, and I'll return to systems in a minute, has a really interesting impact in terms of life cycle assessments, because flax is it's a very durable fiber, so it copes really well with recycling, but it's also a very energy intensive fiber to produce. So the initial, it's not like cotton that you can just take off a ball and you can spin. The initial processing for flax takes a lot of energy and a lot of processing. So if we can take a feedstock that's already existing, which is flax, that's in a product, it's a really useful low energy alternative, and it recycles extremely well. And what was particularly interesting with this is an extension going a little bit beyond that, was they managed within the funding call to separate the two fibers, so the protein wool fiber and the flax, but also they recovered the dyes and they put those back into powder form, which you can see in this image on the right, and they managed to re-dye virgin materials with those synthetic powdered dyes. And they had the same color consistency and color hue as virgin dyes. So that was a really interesting aspect of that project. This was showcased at the Future Fabrics Expo in June 2024. And it really, it's really interesting to kind of see the public's response to these things. So where we can, we try and share and disseminate our work through lots of different spheres. And the image, the kind of bottom middle image, is some work that was undertaken by our PhD student, who is now, so she's graduated. She's Dr. Nalini Neskamikon, and she's now working as a lecturer at Thammasat University in Thailand. So she came to De Montfort as a student in order to address what she saw as some of the issues around sustainability in textile production in Thailand. And she developed a really interesting process using enzymes for coloration, so creating long chains for textile coloration without using any synthetic dyes. So it's a really interesting space to be in, this biotechnology space. And the image on the top right, you can see not only have they dyed some fabrics with the virgin dyes, but they've also managed to create them into screen printing media as well. So the next little set of slides really explore some themes and research for my book chapter. So this was in a recent publication, and its value definition is sustainable textiles production and consumption. And it's really thinking about how do we define the scope of the textile designer, because that's my background. My background is in textile design, but looking at how do we take a systems approach and how do we amplify the impacts that we can have. And one of the ways, as you can see, that we do that within our research group is that we work within teams, and we have, engineers working with designers, working with garment technologists, working with technical specialists in fiber production, working with industry. And that's how we kind of embed that amplification. So if we're thinking about the context of developing solutions for tackling industrial societal issues such as environmental sustainability, we have to really frame those as different roles that we play. And I think that's really helpful in terms of thinking about the capital that we have as designers, the capital and the how our values infuse that as well. So textile design has really formed through a series of different intellectual and physical capabilities over generations and decades. It's practiced within specific cultural and industrial contexts, and a specific terminology has been developed over centuries of tradition of practice. So in this ways, we can think about the role of the textile designer and how that has undergone conceptual and perceptual changes. So when I'm educating students, when I'm working with my, from undergraduates through my MSc students, through my PhD students, we're always thinking about how do we define the scope of what the parameters of our research are, the parameters of our ambition. So we have these different roles that we play, and I think it's really important to always underpin what we're doing with these roles. So we've got the role of the researcher, identifying and reviewing approaches to design that are essential for the future of the sustainable paradigm in which we're all working. There's no alternative to working within the sustainable paradigm. If we're on a planet with finite resources, we have to move towards this. And there are so many economic benefits from this as well. So this particularly relates to the potential of two models of textile design. So co-design, based on the principle that when consumers are involved in the design process, they are more likely to make thoughtful and intentional purchases, avoiding overproduction and hyperconsumption, and design for narrative or storytelling. So where a user shares a unique personal history with the product, such as how, when, why, or from whom the product was acquired, and a story linked to the product, such as unique type of fiber, a textile with a particular cultural significance, etc. And we could see this when we did the exhibition at the Future Fabrics Expo, where people, just the general public, so these were people from industry, people who were from academia, who were students, who were, the press, they were so excited about this idea of using an enzyme, so an enzyme derived from, a naturally biodegradable enzymatic source, such as some of our enzymes, for instance, of nalinase coloration enzyme was derived from fungi. So you can think about that story of where that enzyme came from, but also this idea of taking that process a step further than re-dyeing. It becomes the story of that process becomes really fascinating, and that it becomes imbued with significance, and it just becomes quite interesting. I think that is so. The technical aspects are so important, but the storytelling and the human aspects are also really important to drive the concept And if we're thinking about the role of a curator, global cultures are increasingly sold the concept of consumption as a defining characteristic. So the throwaway model of ultra-fast fashion is an alien concept to so many cultures across the world, but through aggressive marketing, social media, and shopping acts designed to be addictive and release dopamine, many rich heritage textile traditions are being subsumed or lost. So it's thinking about how designers have the opportunity to mediate the pace and force of this consumption. So through processes which I call acts of curation. So processes of owning, consuming, caring for a textile garment, the post-consumption phase at which a garment might be discarded, what happens to that? If we're thinking about the circular economy, the idea is that the designer has the opportunity to develop a service model of textile design, which develops not only from a responsible design model, but creates an outlet for further creative problem solving, an income stream to the inventory in a person's closet. So what as the designer, when we're working with our undergraduates, our master's students, we're encouraging them to think, if you are responsibility for this garment beyond the point of sale, it comes back to you. What's the next stage of its life? How do we reimagine that? Does it get reworked? Does it get customized? What are the elements to extend the life as long as possible of this garment? And generally speaking, we're always thinking about the circular economy. So this is always in the background of our mind, but we're thinking about the circular economy as a system. So in the circular economy, this sort of approach is described as creating emotionally durable design, or design for longevity. Whereby through creativity and dexterity and design, designers develop a product which evokes an emotional response, in which the user gets to know and assign value over a long period of time, otherwise known as slow fashion, of course. So the context for the chapter that I've described, but also my current enterprise and research work, is really exploring how the inherent skills and attributes of a textile designer are essential for the transition to the circular economy, which, if fully realized, could be the biggest shift in the fashion and textiles economy since the Industrial Revolution. So if we take the Ellen MacArthur Foundation definition of a circular economy being one that's restorative and regenerative by design, and which aims to keep products, components, and materials at their highest utility and value at all times, and a move away from the linear economy, we can think about this as a system and a system problem to solve. And systems theory describes how relationships between elements and components work within a context. So how changing one part of a system changes the interactions and feasibility and continuation of an entire system. So as we know, an ecosystem is a complex system whereby habitat and biological systems such as plants, waters, geography interact. And so systems thinking really emphasizes interconnectivity in a world with finite resources. With my students, when they're designing something, I say we have 100 billion garments being made per year. Why do we need your garment? What's special about it? What is the story of this garment? What will it bring to the economy? What will it bring to the people using it? So we're thinking beyond a throwaway product. We're thinking something that has value and longevity. As the visionary architect Walter Stayhill, writing in the 1970s, stated, it's a resource-retaining extension to product life and design systems, which ensures materials circulate back into production through his kind of 4 R's, which were reuse, repair, reconditioning, and recycling. And of course, together with Genevieve Ridet, the work evolved into the concept of the circular economy as it's known today. And what's really key to this is thinking about it's extending far beyond recycling and reusing materials, although, obviously that's key. But in prioritizing design and manufacturing choices, which set out the ultimate aim, not only natural resource retention, but continual employment opportunities, with recycling being the final choice, not the first choice. And in this way, it requires social, technological, and commercial innovation. From an economics point of view, in maintaining value and performance of stock, as Stayhill says, replaces value added of flow, and utilization value replaces exchange value as a central notion of economic value. Put simply, this considers products as stock where the monetary value of the product is not situated only in selling it, but in creating income by enhancing its value and extending its performance through repairing, upgrading, and reusing. The circular economy of textiles is really one about value creation and shifting the needle, as was identified by the UN in their Sustainability and Circularity global roadmap in 2023. They set out 3 priorities to develop systems change, shifting consumption patterns, improved practices, and infrastructure investments. These were developed into a proposal for 9 building blocks, which address the key drivers of environmental and socio-economic hotspots within the value chain. In particular, the call for each stakeholder is to take action themselves or to work with collective actions with policymakers, financial institutions, raw material producers, NGOs, and innovators for scale and pilots and scaling change. These global challenges require not only technical and design knowledge, but an understanding of how to situate fashion textiles within technically and culturally informed positions. Textile designers are involved in decisions which account for up to 80% of a product's environmental footprint, and a high percentage of that footprint also comes in the laundering stage. So it's thinking about how is a product used, and those kind of user trials are so key and important. We're looking at a shift towards legislation requiring digital product passports, how fibers and fabrics are created and sourced, and the ecological and social impacts of fibers and fabrics. And these become increasingly transparent for brands and consumers. We're looking at, we're looking at legislation, particularly in the EU, which deals with 16 different sets of rules and legislations. We're looking at harmonization across the EU in terms of some of the digital product passport and other extended producer responsibility legislations. It's a very dynamic space. It's a very interesting space. But what's kind of key about this is really thinking about the story of where fibers come from. Simplistic approaches, such as emphasis over one fiber over another, can result for one problem being substituted by another. So within the UK, we have the Green Claims Code, which offers checks and balances to claims. So claims have to be substantiated. You can't just say something's eco or green. You have to determine with quantitative and qualitative data what that means in a way that the consumer can understand. And we see similar competition and market authorities across Europe enacting that. And they have leveraged fines recently between 1 and 40 million euros on companies that they deem as not responding and caring about the authenticity and the accuracy of their data that they are presenting. So this has real economic issues here. In my work, the emerging field of transition design provides a design-led approach to look at some of these sustainability challenges across a whole range of different sectors and issues. Transition design aims to create small networks of projects which build together to work on products where the sum is more than its parts, so small-scale products which test ideas. Transition design is biomimetic in nature, so it draws on the complexities of biological systems, examining each part of the system in turn to understand its role in the project space. So here's a part of the mapping of a system. I was invited to an event at the Centre for Circular Design at the University of Arts London, where we were talking about valorising and exploring the potential of wool as a sustainable fibre in the UK. And this draws from transition design methods. So this core diagram is a data visualization of the interrelationships between actors and networks in wool. Through mapping out key stakeholders, each of the connections and complexities of a wool system are apparent. And within that, we can see the where the elements of the core diagram overlap. So these become micro networks, and those micro networks are indicative of the smaller groups that you may be pulled together to solve individual problems. So transition design principles are really thinking about interconnectedness, but also real world applications of solving problems. For myself, on a basic level, I've done this successfully with my students through a project I call Story of a Garment, where they look at the impacts inherent to an item of clothing in their wardrobe. So they start with something that they have an existing relationship with, so something that means something to them. It could be, a jumper that their mother knitted for them, or that they were gifted by a sibling. It could be a piece of clothing they've worn at an event such as a wedding. But we look at the entire system of that garment, where it's come from, where the fibers have come from, and we examine those within the framework of the UN SDGs, so all 17 of the Sustainable Development Goals, to find one or two aspects of the problem to revision for the future and find solutions for. So this enables them to develop and explore their own values in their story of themselves as a designer and addressing values for the global fashion landscape. And this is really key to the development of a sustainable future. It's thinking about how do we catalyze the next generation, to borrow a metaphor from our enzyme colleagues. So it's really thinking about, although it's not with it made implicit to the students when they're dealing with this, engaging in a transition design process which draws on interrelated and mutually influencing areas, having a vision, exploring theories of change, mindset and posture change, and new ways of designing. So within this, my teaching philosophy has been informed by principles of education for sustainable development. Though the originator of this term, Stephen Sterling, now prefers sustainable education, but I still call it ESD. As I've mentioned, DMU is an academic global chair for UN Sustainable Development Goal 11, led by Dr. Mark Charlton, and I use the 17 SDGs as a template for showing all the realms in which textiles intersect with, in order for students to identify and inspire what they want to do with their sustainability journey, and also to identify what enrages them about the sustainability, fairness or unfairness that they see around them. And this creates transformative rather than transmissive approaches. They identify their own approach, they identify their own values, what they're interested in exploring further, and they take it forward and they propose design-led solutions to some of these problems. And this is really key for employability and future-proofing, for getting students ready as the next generation designers. They can go into industry as a series of design activists and help support this transition to the circular economy. The context for this is the Great Acceleration. So as we are commonly aware, our geological time is divided into epochs, which measure shifts in structures and shapes, such as the Jurassic period. So the current era, the Holocene, has been suggested as being superseded by another more human-centric or human-disrupted epoch, which has been proposed as the Anthropocene, drawing from anthropos meaning human and as an anthropology, and scene meaning new, underscoring the significant impact humans have made on the planet. This term was coined in 2000 by Paul Crutzen, a Nobel Prize-winning meteorologist and atmospheric scientist, proposing that the Earth had left the Holocene and had driven our current geological era, which began during the last major ice age and 11,000 years ago. In my research, I framed the discussion as fashion and textiles in the Anthropocene to emphasize that our design and manufacturing outputs have real impacts that mindful textile design must take into account. So if we think about the start, the Anthropocene is still a concept which is under current debate, but there is almost no dissension around the idea that we have had as humans a huge influence in planetary systems for which the global north is vastly responsible. So this corresponding increases in pollution and greenhouse gas emissions has been termed the Great Acceleration, inspired by the period from 1950 onwards, where we see this huge explosion of different impacts on the environment, illustrated here in this diagram, things like pollution, greenhouse gas emissions, and other kind of global issues. So it can feel large, overwhelming, and global. And exploring stories as a means to ground and make sense is a way that I guide my students and also guide myself through this. I'm just going to return to systems thinking for a moment, so a slight pivot here to another chapter that I wrote with my colleague, Angela Davies, who I've already mentioned is an associate professor of garment technology here at De Montfort. And just thinking about leveraging textile testing to ensure garment quality, longevity, and transparency. But at the point of what we're looking at is thinking about a leverage point. So in systems thinking, a leverage point is a place in a complex system whereby a small amount of change or disruption has a disproportionate effect. In short, a small change has a big impact and can be used to reset behaviors. So in this chapter, I had the idea that in order to accelerate sustainability, which was the theme of the book, we could propose for the fashion and textile sector that brands communicate the durability and longevity of their garments in order to create a leverage point to shift consumption behavior by explicitly demonstrating a brand's commitment to the quality of garments. So within our testing facilities, we have a full house of industry standard informed by other European Kitemark or BSI, British Standards Institute, textile standard testing facilities. So we do quality tests, we do safety tests, we do a full range depending on what the product performance is and depending on what the product outputs are. So my colleague and I, Angela, who was brought in for her expertise on garment testing performance, proposed that in this very complex landscape of ultra-fast fashion and hyperconsumption, a leverage point for change towards encouraging garments to be bought by consumers which had durability and longevity as their key points, that we could use this as a way of disrupting the status quo. So brands conduct tests of pilling, seam strength, color fastness, safety. These were more apparent when buying a product, such as at this point that we were looking at this, we were thinking in the future, the digital product passport could be part of that. And I think that's still a really key point if we're looking at unfolding this massive wealth of information for the average consumer. If a consumer could understand that you could get 100 washes out of a garment, you could influence buying behavior, and this could be framed within the design for durability legislative drivers. So, but let's be clear, the circular economy is obviously something I'm a proponent of. It will never address the global challenges of sustainability if it's still a business as usual model of consumption, particularly in the global north. So we're thinking about how do we address over and hyperconsumption with a sustainable number of garments posed at 5 garments per year, as opposed to the current average UK buy of 50 garments per year. There's a figure circulating that 100 billion garments a year, I've already mentioned it, are produced in the world globally, or 400 billion meters of fabrics, and that we have enough clothes to last 5 generations. Going back to the question I asked my students, why your garment? Why do we need this? Be mindful of what you're using. Be mindful of your materials. I would actually refute that we have enough garments for 5 generations, because most garments in the hyper-fast fashion world would be lucky to make it through 5 washes in the washing machine because the quality is so poor. So this is really where exploring the idea of a textile and fashion economy based on durability and longevity, and giving that qualitative and quantitative data to the consumer of how their buying behaviors can be contributing to the safety and longevity of the industry is really key. And this is a really a commercial decision now. This is something that brands can leverage, particularly with the much lauded extended producer responsibility legislation that's coming in the EU, bits of the design for eco sustainability legislation that are coming through in the EU as well. Parts of those go live in 2028. They're talking about parallel legislation in the UK. And we're looking at an atmosphere in which the Competitions and Markets Authority in the UK can fine brands up to 10% of global turnover if they don't adhere to accurate reporting on their environmental claims. And textile testing is in many ways very simple, but it's also very robust in terms of the environmental claims and how it can feed into life cycle assessments for garments and for manufacturers. Slight pivot now as well. This is really kind of building on some of the other work that we've done here at De Montfort. So in a recent project that I worked with a colleague, Professor Rachel Granger, in our Faculty of Business Law, who was the PI, I, along with Dr. Angela Davies and our technical instructor, Kay Radford, were working with local industry in Leicester we were leading on green product and process innovation and marketing and process plans. And what we were doing was exploring some of the different aspects of local industry that could be worked with in terms of, we developed knowledge exchange projects with local industry. We were looking at how do we support, in a real scenario, local manufacturers. Testing underpinned a lot of that. So thinking about how, what other tests that they could do with their garments, other tests they could do with their products to really have a portfolio that proved the quality and durability of the garments they were making. So when a brand was coming to them, they could prove that they would have better brand satisfaction and better customer liaison by having a more quality brand, but also exploring, things like life cycle assessments. If you substitute one fibre for another, what are the environmental impacts of those? So that work is ongoing. We've also been working with embedding students at both undergraduate and postgraduate level. And this is something I'm showing you because it led into another piece of work that we were doing. So the Leicester textile sector is very dynamic. We still have at least 50 factories within, a few miles of campus. We have a factory that's just down the road that does really innovative, sustainable dyeing. The sector is drawn from incredible models of entrepreneurialism, drive, and it's a really interesting system if we think about the textile system in Leicester. On the back of this, I was contacted in February 2024 by a contact at Innovate-Gh, the innovation funding body, research industry funding body that we work with, who were familiar with this project and asked if I could recommend a factory in Leicester for a group from Nigeria for the Innovate-Gh we're hosting for the Nigerian Sustainable Manufacturing fact-fighting mission for transitioning the Nigerian textiles economy towards a circular economy. So we hosted a delegation and we had a factory visit on the basis of this. And on the back of that, I was asked to join the UK-Nigeria Circular Fashion Global Innovation Network Steering Committee. And there are three pillars, one of which I work with my colleague Zara Odieu in Nigeria on, particularly around redefining chemical use in production and manufacturing. And that's a really vibrant and very broad set of different expertise is represented in that steering committee, looking at different ways in which the industry can be supported towards circularity. And this is an ongoing committee we're involved with. On the basis of this, my colleague Zara and I wrote a bid within the redefining chemical use pillar, which was receiving an Innovate-Gh Global KTN, Global Alliance Africa Lead Customer Programme Fund. So the project we developed centred on drawing down textiles engineering and materials research group expertise, particularly my colleague whom I've mentioned, Dr. Edward Smith, who's our coloration specialist, to devise a dye house in Lagos on developing sustainable dyeing techniques for traditional Adire wax resist coloration techniques, whilst retaining the intangible cultural heritage of the process, which has been recognised by the UN as a special cultural focal point. So the project was conceived as open source, so the project will be shared and the outputs will be shared, and we have just finalised a report. There's going to be an event at the weekend working with other dye houses to explore some of the different impacts for different technologies. We took a systems approach on this, looking at the entire dyeing system, analysing the technologies, the dyes, the equipment, the filtration, the water, the effluent, just to see what it was a very short project, only 6 months long, but just to see what the immediate impacts could be around that. So we particularly identified 3 KPIs to keep performance indicators on dye house practice, looking at alternative chemical auxiliaries for the vat dyeing process, and improvement to effluent water treatment processes. We worked with Ms. Itfp-Gh Madu at Afric-Stable, her label, based in Lagos. And she has been such a visionary in terms of really celebrating this textile artisanal process, whilst also finding solutions for some of the difficulties with effluent and really identifying what some of the improvements could be. So we were successful in determining a solution to the problem of the dyeing within, obviously, the limitations of the short time scale. In particular, looking at the pivot away from vat dyeing towards a reactive dyeing process, and what we sought some extra support with one of our brilliant PhD students who's got life cycle assessment. She's a particular water specialist. And we identified that there were some real improvements from just swapping the dye out and also swapping out some of the technologies in terms of the filtration technologies, using some of the membranes, etc. So our PhD student, Clemence Belbach, is a life cycle assessment and water footprint expert, and she ran comparative studies of the dye, water and the waste. I'm happy to share the report after it comes out if anyone's interested in this. She used her experience in augmenting the standard ISO for life cycle assessments of water footprints, and explored how things like eutrophication, water toxicity, and the alkalinity versus the acidity of the effluent were influenced by some of the incredible technologies that Itfp is already using at Afrikstable in her water filtration, but also this kind of pivot to a different dye stuff. So this is ongoing work and something that we're particularly interested in exploring and developing further across the sector, and very much work in progress. So even though this project is finalised, we're looking at future work and developing some other outputs from this. A huge difficulty in writing the project that we found was the paucity on data in the sector. And I think that's a really interesting issue when we're looking at how do we ground our funding bids. So I think it's wonderful seeing some of the, the different presentations and the papers that we've got, where we're looking at the very active and kind of dynamic system of research going on, particularly within the context of textile production in West Africa. And I think that's so helpful in terms of the, just this idea of like the energy around shifting the sector and moving forward. So continue and watch this space, please. So yes, there's some, just a few more elements in terms of the timescale. It was a very short project, but it was a really interesting project. Another alternative that we explored was a different auxiliary. So if people did want to continue using back dyes, there was a more efficient auxiliary. So there are a few different outputs that we identify within the report. So in summary, systems and stories are inherently human. They really help us organize information and moments and experiences into a coherent whole. In particular, value and values function as drivers for understanding ways in which we consume and behave when making purchases. They're also driving what we do as designers. And I think this idea of using the system and having everyone taking part and everyone, it's really interesting being in this circular economy and circular textiles area at the minute. It's not led by academia, it's not led by industry. It's not led by NGOs, it's not led by funding bodies. Everyone's in the same space together and solving these problems together. And so in an age where consumption and narratives are increasingly driven by AI, textiles really connect us, I think, uniquely to a sense of authenticity, to a sense of our identity, to a sense of what it is to be human. And it's a really exciting space to be in. And I thank you so much for coming along and listening to me speak today. And I'd be very happy for anyone who wants to connect with me on LinkedIn or drop me an email. Thank you.
Yeah, truly awesome, eh? Give her a better round of applause. Professor Claire.
Thank you.
Oh, a better round of applause for her, please. Questions, let us hear them. I will do them within 15 minutes. Are there questions? The first one dealt with the advancements in e-textiles in the era of sustainability. Okay, I have a hand up. Can someone help me with the... those of you who want to ask questions, can you kindly come forward so that it makes it easier for us? Okay. Okay, you can give it to him. Our first questioner is Papa Kwame Nafin. Please, who is this going to? Is it
Professor Claire
Lepine?
Yes.
Okay.
I saw something on leveraging tacit knowledge for textile.
Make it a little audible. He's listening.
Okay. Leveraging tacit knowledge for textile economy or something.
Leveraging
tacit knowledge.
Tacit
Yeah.
knowledge. Yeah.
Okay.
In our part of the world, it's patent that we hardly share. Once somebody has gone to a certain experience and acquired some knowledge, it is difficult. In fact, he does, because of selfishness, mistrust and other things, they don't pass on that knowledge. So how do we combat that? We forget that sharing that tacit knowledge is also a way of preserving that knowledge and then creating new knowledge. But we hardly do that. So how do we do that? And for Professor...
hold on.
Okay.
Prof, did you hear him?
There was a question around how do we share tacit knowledge? I didn't quite hear the second part of it.
Yeah, what I'm saying that in our part of the world, we hardly do that. So how do we, if you like, mitigate that?
Yeah,
So
no, I think it's something global. I think there's so much about the textile industry is so hidden, isn't it? You know, and it can be even down to the point where a lot of fashion designers don't necessarily know that a wool is a protein fiber and that a silk is a protein fiber and that a polyester is a plastic fiber. So I think this is where education is really key. And there's a limit, let's be real, there's a limit on how much people are willing to spend learning about their textiles. But I think there's some really interesting opportunities with digital product passports that you can actually expand a whole world. So you've got the technical knowledge that comes with that. So you've got the things like, as Thea was saying, how do you recycle something? How can, what do you do with it at the end of its life? Don't throw your e-text. We're having a lot of fires in our recycling centres at the minute because people are throwing vapes in the recycling, and you end up with a fire. So it's thinking about that kind of consumer behavior is really important. How do we support that? But also when we're thinking about that, leveraging the tacit knowledge, where did the garment come from? Who's made it? So I think if you look at Afrik-Starball, what my colleague Itfp-Gh, I call her Iffy, everyone calls her Iffy. What Iffy does is she's got like an open door policy. Everyone can see what she's doing every time they're dyeing something, every piece of fabric, the new motifs, the new collections. Obviously, she produced the textiles that became the Nigerian Olympic team's opening ceremony clothes. It's really creating that sense of engagement with the consumer. So sometimes it's like the literal story of that garment, and other times, if we think about the garment as a person, what would their biography be? So how do we showcase their entire life? Have I answered your question? I don't know if I have. I don't know if you've got something to add as well, Theo, from an e-textiles point of view.
All right, thank you very much. You have another one for Dr. Theo, Professor Hughes. Okay, Theo, please listen.
Hello.
This is yours.
Pardon me if I don't pronounce it very well. I saw this framework on cooks or something. Framework.
Yeah.
Cooks,
there was something I picked on. I realized that, in fact, let me say, this morning I picked a certain shirt. When I wore it, I realized that my emotions and everything was some way. Then I picked this white one. I realized my face has lightened up. So I don't know whether the texture and color and design has something that affects your emotions and other things. So if you can, thank you very much.
All right.
Yeah, no, that's a very interesting point. And yes, it definitely can
Again.
Theo, this one goes to you also.
I'm much concerned about the textile integration part of the presentation, and a little bit biased technically as far as weaving is concerned. So in the presentation, you made mention of these electronic yarns being used as weft.
Yeah.
Possibly or technically as weft inlays. And my question is, why not also as warp inlay, or the possibility of blending the two directional fabrics, considering both warp and weft? And possibly, or hypothetically, is there any chance that if you have it in both warp and weft, it will increase the sensitivity of the fabric?
I missed the very end part of that, I'm afraid.
In your presentation, you identify the integration as weft.
Yeah.
Any technical reason as weft, because we have two directional yarns in weaving, you have warp and weft? Or is there any future research to consider the inlays or the insertion of these yarns in both directions to increase the sensitivity of the fabric?
Oh, thank you. I got that this time. So the main reason it's a weft is because it's easier, to be perfectly honest, with particularly with the setup that we have. But also, when you're making the warp, there are quite a lot of sort of mechanical forces that would go onto the yarns, and that would potentially lead to breakages, which is why we have preferred to use the weft. There are people that do other types of electronic embedded yarn that do use both warp and weft. We could definitely increase the density of sensors using both, but for most of our applications, we don't necessarily need to. So I think for our work, probably we would continue with the weft, but there are people that do use the warp as well. And particularly you can get some e-textiles where those interconnection points are actually really important for function.
Okay. All right, so the next question goes to both of you, both Claire and Theo. Kindly take a listen.
Okay, so to Prof. Theo, I would like to ask, in your presentation, you made mention of certain tests in the area of the electronics integration into the yarns. You talked about the washability and the durability, but I didn't hear that of the impact of the integration of these electronics on human, because most of these products will be used on human. I don't know whether there has been a test to ascertain, because even with the physical integration, I can see ridges and strips. So some level of discomfort may be there. But apart from that, these electronics inserted into the yarns may emit some form of rays or anything. I don't know if any of such test has been done to prove whether it has no effect on the skin of human beings. And to
Claire.
Yes, to Claire, I want to find out in the area of sustainability. In the early part of your presentation, you were talking about the issue of, I think, upcycling, recycling, and conversion of some materials back into other textile products. I've been looking at waste or textile waste and how we can convert them back into other textile products. But my concern is with the natural fibers and the compromise on the quality. I'm thinking it would be easier to convert synthetic fibers back into other textile products than natural fibers, because natural fibers, I believe, has its expiry, some form of expiry on it. So to convert it back into other product, has any test been done to check the quality and the durability as talking about sustainability? Thank you.
Do you want to start, Thea?
Yes, thank you. So thank you for your interesting question. It's a really good point, because, yeah, we can do whatever in-lab tests we want, but if it's not tested on a human, then, I mean, you need that feedback. So we have done human trials with some of our e-textiles, and we have had feedback on comfort. Over the years, sometimes we've had to improve the comfort, but generally speaking, for the things that we have tested, such as the fall detecting sock, for example, that's not caused discomfort. In terms of the actual electronics affecting humans, we pretty much exclusively use consumer grade used in wearables. So while we haven't done specific tests with it, there's nothing there that should affect or be detrimental to the human skin. Of course, if this was to become a commercialized product, there would be additional testing done.
Thank you very much, Theo. Claire.
Yeah, that was a really interesting question. So one of the reasons that the project that I showed that Professor Jinson Shan had been working on with Dr. Edward Smith and colleagues at Loughborough was a wool flax hemp, wool and flax, or wool and hemp blend, is that because those are both bast fibers, and bast fibers, as we know, are stem fibers, so they're very strong. So when you actually go to recycle them, you can actually recycle them multiple times because the fibers are inherently very long. Obviously, that's not necessarily the case with cotton, which is a much shorter fiber, which is why it's softer and requires less processing. However, I do know of a lot of interest that's being played into taking a short fiber feedstock, and then enzymatically recycling it, so you can break down the bonds, so break down basically the chains of molecules, and create a liquid dope, and that becomes a viscose dope, and you can actually turn it back into viscose, similar to the taking wood and turning it into viscose process. Is pretty much exactly the same process. So pretty much all natural fibers can be recycled in some way, but for some very short fibers, you're looking at enzymatic or other viscose processes. Does that answer your question?
Yes. Give a warm round of applause.
This is why I love linen. And also, big shout out for linen, because it's a carbon capture fiber as well.
Sure. So we are taking the final two. One is online.
Can I also ask a
your
question?
hand is up.
Okay.
Yeah, Roland, we are listening.
Okay. So my first question goes to Hughes, Professor Hughes. I want to know, has there been a test on these textiles in relation to certain medical issues? I want to know first whether it's reaction to certain medical conditions. Then secondly, also with the yarns, has it also been integrated with all kinds of yarns, i.e. natural or artificial, and how its efficacy is, and also its longevity? I also want to know about that. Thank you.
All right, so Theo, hold on. The very last question also goes to you. So let's take it and then you address it and then we are done. Thank you very much.
Thank you very much. I'm very much interested in eco-friendly manufacturing processes. So my question is, how are you incorporating this or adopting this in e-textiles production? Thank you very much.
Thank you for all of those questions. Those are all very interesting. Start with applying to medical situations. So e-textiles have been used in medicine to some extent, more in the well-being space, really, than medicine at the current time. The e-textiles that we've developed aren't commercially available, so they haven't been applied to medicine, like an actual medical scenario. The closest would be near fall detection, but that wasn't used as a clinical diagnostic tool. Regarding the fibers, we primarily use polyester for a few reasons, but we have tested other materials, including natural fiber sources. There are some challenges, particularly with braiding. So the braiding machine puts quite high tensile stress on the yarn. So while we can get a good covering with cotton, for example, it does break. So we're looking at different materials at the moment to try and improve that. And then final question about the eco-manufacturing. So we've done a lot of work towards the manufacturing technology for the EONs. At the moment, it's primarily a manual process, so we do have some automated processes involved. I would say that the only obviously we try and reduce waste as much as possible, and doing it manually, you get a higher yield rate. So that's really sort of from our research, I suppose, how we're trying to improve the kind of eco credentials of that process. There are other e-textiles though that are looking particularly at, say, for example, biodegradable materials in for manufacture. So there is a large space in that area, but with the technique that we use, yeah, I suppose reducing waste is the main thing. Hopefully that answers your question. Okay.
All right. Thank you so much. We are very, very grateful. Okay. Okay, so one of our board members would want to ask you a follow-up. He's doing a follow-up. Professor Kofi Howard.
Thank you very much. I hope you are blessed. Very insightful presentation.
Going to Theo or Claire?
And it's going for both of them and all of us. And all of us. There's this thing that has been bothering my mind as a teacher. And as a teacher of fashion and textiles. And I've been posing that question to my students, and we are all struggling to find an answer. And once we are in this conference, I think this is an international conference, and I wish we could find a solution to it. We are in this world today. We are struggling to make time. Sometimes you say you'll be doing dual work. You're supposed to be at the same place at the same time. Our Vice Chancellor came here, and he has to leave. All because we don't have a solution to make him stay here and be at that same place at the same time. Talking about time and space as a theory. Professors, I want to find out if we could generate, we're talking about smart textiles, engineering, textile, electronics, integration, everything. I am thinking we should be able to find a solution to this situation where we could have one garment that if I put it on, I'll be duplex. I could be at the same place here and also be in Kumasi teaching. Is there any solution to that problem? Thank you very much.
Theo. Claire.
I mean, didn't Star Wars come up with a solution to that in 1976 with their holograms? The Internet of Things is really interesting, isn't it? Where you've got garments that are connected to the internet on a more kind of slightly serious level. I think the trouble is we have to set our parameters, don't we? We have a finite number of breaths and hours on this earth, and there's an infinite number of things to do. So maybe it would turn back to those 17 UN Sustainable Development Goals and see where your priorities lie. I apologize for the noise. We're having an incredible thunderstorm here, so I'm going to turn my audio off while Theo answers.
Theo, what of you?
So I think the comment about the Internet of Things makes complete sense, because I mean there are ways that you can put sensors on somebody and then that could replicate something somewhere else, but it does come back to you've only got so much time still, and you've only got so much cognitive load as well. So you could in principle be in two places at once, but then you're having to focus on two things at once. So yeah, in principle you could do it, but whether that would work is another question.
Very interesting.
What a great question.
All right, thank you so much. It's 11:10. We are supposed to break, and so we will take a very brief remark from our National Board Chair, Professor Charles Frimpong. So, Prof, over to you.
All right. Good morning, everyone. I hope you can hear me
clearly.
All right. Thank you very much. So, I would want to thank everyone for making this possible. Indeed, I would have loved to be there, but I have a meeting here for the good part of the day tomorrow. And so that is why I'm not there in person. But let me just say this, that I am highly impressed at the increased number of international presentations in this conference. And for me, it lends credence to our formidableness, even if you consider the fact that we've not been around for long. I think we are making giant strides, and it is very, very remarkable. Now, maybe going forward in the coming years, when we meet as a board, we'll be looking at making our presence felt in the country. Yes, as individual members of ITFP, we are represented, on some other boards or committees, but then ITFP as an institution should take a central stage, especially when it has to do with government policies and programs that influence the textiles and garment sector. Underground, we are doing, as individuals, we are doing our own part to bring ITFP to the fore. And I believe in the coming years, ITFP as an institution will be able to take that central stage. And so these are some of the things that we should be turning around in our minds as we go on forward. And when this happens, we would expect that as individual members of ITFP will make our voice heard. For instance, the government now is thinking about ensuring that, and it's not as if it's a new policy, there's that sometimes when the policies are made, they are not followed through. But let us hope that this time around, we'll be able to press home, that development. Now they are thinking about ensuring that uniforms, are made here in Ghana. Even though there are challenges with our institutions, but they still want to do it because that's just the way to go. I mean, if you don't support your own, how do you expect, your industry to prosper? Especially when you know that is one major, employer of labor in your country. And so these are some of the matters that going on in the coming years, we should avert our attention to as an institution. Okay, so I would want to thank you so much, and I wish you well in your deliberations. And then for those who traveled, I wish you safe travel back to your destinations. Thank you very much.
Oh, a round of applause for him, please. He still has that sweet, silky voice in place. Thank you so much, Prof.
Thank you.
All right. So, you wanted to ask a question, contribute. Please. Okay, just 10 seconds.
Yes, thank you. For Prof. Howard's question, I think you have to engage the cosmic dimension.
All right. So, our Prof. will be leaving us, but he will do the dissolution of this first aspect so that he can leave. But, Prof., I beg of you, let me do these quick introductions, then you can ask leave of us. So we have our Director of Internal Audit here, a member of the management team of the university, Madam Elizabeth Obeng. Thank you so much for coming. We are very grateful. Very, very grateful. Let me also quickly introduce to you the membership of the LOC. But let me start with the Scientific and Technical Committee. Professor Charles Frimpong, who is our National Board Chair, and also with the University of Science and Technology, the Kwame Nkrumah University of Science and Technology in Kumasi. Professor Richard Nipakpo Akwe, TTU. Professor Kofi Howard, KNUST. Professor Kweku Safo Ankama, TTU. Professor Thomas Obeng Asari, KSTU. Professor Eric Busamati Jr., TTU. Dr. Timothy Krenzel, KNUST. KSTU. Dr. Daniel Danso, Amstead. Dr. Ninette Apia, Amstead. Dr. Benjamin Teria, KNUST. Dr. Solomon Mafo Ayesu, KSTU. Dr. Moses Akrofi, TTU. Dr. Isaac Abraham, Amstead. And Dr. Raphael Kenyere Seidu. The Hong Kong Polytechnic University, Hong Kong, SAR. In fact, let's give him a very big round of applause. And he's online. He has been very, very, very instrumental in the organization of this conference. He hasn't slept, and I know he won't sleep. Prof. Ralph, Dr. Raphael Kanyere Seidu, your hard work has not gone unnoticed. Everybody has seen what you are doing. And leadership, I think he deserves an award. Yes. A better round of applause for him, please. And then Mr. George Kwame Fobri, Kumasi Technical University, Kumasi. Now to the local organizing committee. These people haven't slept too. Before I mention their names, let's give them a round of applause. Dr. Moses Akrofi, he's the chair. Professor Richard Akwe, Professor Kweku Safo Ankama, Dr. Abdul Fatai Ibrahim, Dr. Faustina Agoda, Dr. Adjoa Chunibuachum. These are the members of the Central Planning Committee. Publicity, Professor Eric Busamati Jr., Mr. Thomas Bruce, Mr. Moshi Diana Hiamenyo, Mr. Smaila Mohammed Smaila, and Mr. Joshua Kwabna Enim. Decoration, Dr. and Mrs. Ophelia Mefo, Chairperson, Ms. Anita Jakpasu, Ms. Rhoda Basso. Hospitality, Dr. Na Omai Sawyer, Chairperson, Dr. Sarah Ashley Kwansa, Mr. Joshua Kwabna Enim, Ms. Adelaide Oboshisai, Mr. Bernard Atampu-Gray, Mr. James Tete Adamchu. Protocol. This beautiful woman hasn't slept. Hajia Suzy Aku Damali, Chairperson. Genevieve Apo Ajay. Isahaku Gbene Boyong, and Helen Bangmioku Pole. Thank you so much for your hard work. ICT and Media. NS Do Kujoji, Chairperson. I think he deserves some round of applause. The online system has been very, very solid. Joshua Kwabna Enim, Aaron Amankwa, Edwin Nana Kondria, Ebenezer Moses Deborah, Charles Kuma Intim, and Emmanuel Baden. And then the ushering team is led by Cynthia Ejewa Kusi, supported by Bernard Atampu-Gray, and our textile and fashion students. We are incredibly grateful. Let me also announce to you the password for our Wi-Fi. So when you go online now, you will see the Itfp 2025. That's the name of the Wi-Fi. Then the password is ITFP25@TTU, all in small letters. ITFP25 at TTU. Now, those of us, I'm talking about the participants who haven't yet registered. Kindly go and register, take your pack and your tag. Thank you very much. Prof, kindly do the dissolution of the first session so that we can take our break.
Thank you. Good morning, colleagues and friends, all protocols observed. I have personally enjoyed it this morning. Especially, I'm intrigued with the sustainability aspect. Because I am water biased, everything that we use eventually lands on the Earth's surface and eventually affects the water hydrology. So anything that we do, I'm more interested, especially with the sustainability, and I'm happy with that project. I want to thank all the organizers. I want to thank everybody on board. As the VC said, we wish you a successful program. On this note, I stand in the stead of the Vice Chancellor to dissolve the morning session. I wish you a fruitful day. Thank you.
Okay, so we are going to take a roll call of the institutions that are present. And we're starting with our big brother, Kwame Nkrumah University of Science and Technology. You just rise, you rise. He says you should make noise, make noise. Kumasi Technical University. Oh, you rise for us to see you. Okay, Takoradi Technical University. Rise, rise, rise. Okay, thank you very much, Prof. Yay! Accra Technical University. Accra, oh, welcome back, welcome home, welcome home. Those in Accra, Takoradi is your home. Cape Coast Technical University. Yeah. Cape Coast is the spouse of Takoradi. Ho Technical University. Yeah. I hope you brought some Adame. Then Amstead. Oh. If I had said Amstead, you would have heard. Gambaga College of Education. Yeah. So Blue Crest University College. Yeah. St. Monica's College of Education. Wonderful, wonderful. Prince Osei Tutu Skills and Entrepreneurial College. So beautiful. University of Professional Studies. UPSC Accra. I guess they are outside. Wesley College of Education, Kumasi. Oh, beautiful, beautiful. Welcome to Takoradi. Center for National Culture, Bolgatanga, Ghana. Welcome, welcome. You're welcome. Commander Senior High Technical School. Oh, beautiful. University of Cape Coast, UCC. Oh, welcome, 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 welcome. University of Education, Winneba. Oh, great. Great. Sunyain Technical University. Oh, nice. Thank you so much for coming. Now, when we leave here, we are going to our various conference centers. The first one is conference room 1. Our protocol team will direct you to the place. The conference room 1 and conference room 2 are both in the auditorium. This is 1, and then 2. So this will be conference room 1. Conference room 2 will be behind, just right behind this particular facility. Then conference room 3 is in the TALIF conference room. So you will descend. The protocol team will lead you to the place. Don't worry at all. That is conference room 3. Oh, our sister from the United States of America is here, University of North Texas, Professor Jiyoung Kim. Yeah. Jiyoung Kim. Yeah. The last time we met, we dined. She took some kinky and hot pepper. Yeah. Welcome back home. Welcome back home to Ghana. Yeah, beautiful. So conference room 3 is in the Anand block, and the team will lead you. You have been given your snacks, so you can start snacking on them. We have barely 3 minutes away to start the next session. So we are going to do the official handover to Cape Coast Technical University, who are the next hosts of the conference. Now the team, the organizing team of 2025 should kindly join us here, and then we invite our brothers and sisters from Cape Coast to take over. Yes, yeah, Professor Paddy, Professor Sophie Paddy, and Dr. Ekua Nkrumah. Yes, 2 beautiful ladies. Was it deliberate to be in black? I'm told they didn't plan. A beautiful coincidence. But you are taking over. The black means potency. So we know you are going to be up to the task. All right. So Dr. MFR Agoda is symbolically doing the presentation, the handover to Professor Sophia Paddy. Yes. Long life, potency, and prosperity. Oh, a better round of applause. Professor Paddy, say something. Give us an assurance.
Hello. Good morning once again. In fact, we are highly honored to receive this challenge. I believe it's a challenge. And then we know that with God on our side, we will do it. Amen.
With Christ in the boat, we shall smile at the storm. Yes. All right. Thank you so much for availing yourselves. I think you deserve a better round of applause. The attendance has been massive. We are very grateful. Shall we now move to our various centers? As I said, those of you going to conference room 3 will be directed by the protocol team.
first presentation, which is on smart and intelligent textiles materials, testing and finishing. So that is our sectional head. We'll be presenting on smart and intelligent textiles materials, testing and finishing in room 1. So we are here in room 1. And our first presenter is Miss Christine Atawa. And she'll be presenting on state of the art in fire-resistant textile technologies for aviation, a systematic review. And so, with a round of applause, I hand over the mic to Ms. Christina Tower.
Thank you. Good morning once again. Actually, my presentation is on the state of the art. Okay, thank you. And fire-resistant textiles technologies for the aviation industry, and it's a systematic review. This research was actually prompted because of the recent crisis that Ghana went through, and I asked myself, is there no way to stop these disasters from happening? Because I analyzed about 70 aviation crises, and I realized that over half of them, about 46 out of the 70, had fire outbreaks that were not contained, which led to the loss of many valuable lives. So, the introduction, aviation safety actually is an urgent concern. And because of this, we need to intervene as textiles people. We need to intervene and play a role to help solve the menace. So we have historic disasters, and they've demonstrated rapid fire outbreaks upon impact that were not contained, as I said earlier. And I also spoke on the aviation crisis that were analyzed, of which over 50% of them had fire outbreaks. So how can we help in solving this problem? So there is textiles technology, or technical textiles, which is fire resistant among the others, textiles that can be used to at least curb the problem to an extent. So these fire-resistant textiles in aviation can solve two problems. That is personal protective equipment. So if you have fire impact, you wouldn't burn. Oh, sorry. Thank you. You wouldn't burn, or the problem that will happen wouldn't be that much. And we have for interior finishes of the aircraft as well. So when we talk of recent advancements in textile engineering, they've introduced novel materials such as the meta and para-aramis. We also have the PBI, the basalt fibers, among others, that have been used to solve the fire problems in aviation industry. We have textiles that have been enhanced with moisture properties to retain moisture to curb fire escalations. Okay, so fire-resistant textiles also play a crucial role in aviation safety, where flammability poses risk, according to Alongi et al., who researched on this topic in 2015. There are, however, research gaps in fire-resistant textiles in aviation when it comes to material performance and then in alignment with the aviation safety regulations. And these regulations are the CS 25, the FAR 25.853. And this information was sourced from EARS 8 2020 and FAR 2022. So why a systematic review? The systematic review is to provide results that can be traced and reproduced, and it also prevents, it also helps to curb the issue of being biased when it comes to the subject matter, which actually after doing this work, I have a little problem with, because systematic review using the Prisma method requires you sourcing data from databases. And sometimes when you are done and you use other techniques to source out some of the data, you realize that the database limits you if you don't have full access. You are not signed up to them. If you are using your institutional login, you don't get to access some of the, or when your keywords are unable to pull some of the documents, so it limits you actually. So with the methodology to conduct this research, I use the systematic literature review method, and then scholarly works, peer-reviewed journals, patents, and regulatory documents were sourced out. I sourced out my information from Scopus, Web of Science, and IEEE Explore, because they have content on the subject matter. But when it comes to the patents and regulatory documents, some of them were sourced from other pages or journals. The keywords used include fire resistance textiles, meta-aramid, PBI fibers, thermal barrier fabrics, aviation protective clothing, aircraft interiors, seat belts, and flame spread. And then the Boolean operators that were used were and or. And then for my sourcing, inclusion and exclusion criteria, I used not for the exclusion criteria. So the initial search yielded over 6,000 documents across all databases, which was streamlined using the Prisma flowcharts. So with the inclusion criteria, peer-reviewed journal articles, patents, and regulatory documents, which I spoke on, were used. And then the time range for this sourcing was within 2000 and 2025. So the exclusion criteria included fabrics that are not related to the aviation industry or that have general relations to the industrial textiles and do not have anything to do with fire resistance or aviation. After screening, we took quite a lot of effort, 200 articles, because you may ask why the large amount of articles. The data was sourced from 3 databases, and then Web of Science actually had a lot of information when it comes to fire resistance textiles in aviation. So we had to sort it down to few articles. So data was extracted in the CSV format for the analysis. So trend analysis was also trend in publication was analyzed, and then VOS viewer, was used to identify thematic clusters where the keywords played a crucial role. So this is the Prisma flowchart that was adopted. It's a recent one from Page et al. 2021. So regulatory documents that were coming from different sources were identified, and then the records that were screened, then records excluded, and then the studies that were assessed for eligibility. And then after this assessment, after using the Boolean operators and after doing the exclusion and inclusion criteria, we still realized that some of them were, some of the documents that were extracted had insufficient detail or rigor, and these documents were excluded, resulting in 200 documents for review. So with the findings, we start from the Web of Science. Looking at the year of publications, you realize that there is actually improvements from 2000 to 2023. It peaked. Then it came down a little in 2025, but 2025 is not yet over, so we are hopeful. And then from the countries, actually throughout the research, I realized that Africa, we are not, and this is subject to review though, but during my research, I realized that Africa is not researching on this area. So most of the countries were US, China, Australia, Italy, Germany, India, Singapore. I think Korea too was there, Malaysia. And the first one was on the fire resistance textiles, and this one has to do with fire resistance textiles in aviation. With the countries, it peaked, with the years, sorry, it peaked in 2024, and then 2025 is not over, so we are hopeful. So for the countries that are interested in fire resistance textiles in aviation, US is leading, China is also leading, and these countries were sourced based on the collaborations or where the research took place. So flammability standards, research on flammability standards, which is very important from Web of Science. These are the years that were mapped out, and I think it's improving. And for the countries that are interested in flammability standards in aviation, China, Australia, England, and US still has a wider scope, meaning US is really interested in flammability and then technical textiles in aviation. So, timeline for fire resistance textiles in aviation from the Web of Science database. And this was also generated to give more insight on what was going on. So some of the research categories were on Aramis, graphene nanotechnology, and then other fire resistance composites, smart textiles, and sustainable textiles. Actually, IEEE Explorer also mentioned sensors to determine heating. Be taken. He did not speak about that. That's also an issue of concern. So we move on to Scopus database. China is doing very well in this category, followed by US and then Canada, with Taiwan also trying its best. Okay, so research output mapping years of publication. This for fire resistance textiles in aviation for Scopus database. 2020 and 2022 saw a peak. In 2025, the interest is descending. But we all know that aviation crisis haven't referred to us in the later part of 2024 and then 2025, especially Ghana. So there is a concern and we need to address it. So the research countries, we have the United States and Scopus also leading. Then Austria also trying its best. And then Algeria is actually also here. It's also trying its best. So we use the voice viewer to determine to check out the concurrence of keywords in the article source from Scopus database. Only Scopus database, because the Web of Science, you would require access, or you have to sign into the website before the voice viewer can take information and analyze for you. So we worked with the Scopus database. So the research analysis or our findings from 2000 to 2025, we realized that there are key innovations in advanced fibers like the meta and para-aramis. We have the BPI, basalt, and carbon-based hybrids enhanced by nano-engineered coatings, soil gel treatments, and intumescent chemistries, which is actually something that is being looked at now, including smart multi-layer systems for moisture absorption. So findings indicate a clear trajectory from traditional aramid-based solutions. So what is actually trending now is the sensors towards advanced nanocomposites, smart textiles, and sustainable alternatives. We are in an era of sustainability where biodegradable polymers are being looked at, and the fire resistance industry or the technical textiles industry is not left out. Okay, Performance gains are also notable, with level of oxygen index values exceeding 32% and TPP surpassing 35. So we have aramid BPI caused with PTFE or polyurethane outer shells achieving over 40 CAL by cm cube. Okay, graphene oxide reinforced aramids and silica aerogel composites also deliver TPP about 45, while sensor integrated smart textiles offer real-time hazard detection. So this is what I was expecting the prof to touch on a little bit, to be fair to all sectors, but unfortunately, it looks like it's something that some of us are overlooking, sensor application in fire hazard detection. So with the materials that have evolved, looking at the trend of studies or the trend of research, we have the meta-aramids, we have the para-aramids, we have the polybenzimidazole, and the aerogel composites. Then from those traditional materials, it's advanced to graphene oxide, carbon nanotubes, which have been enhanced with electrical conductivity, and then nanoclays. Nanoclays also popped a lot with among the papers that were reviewed. Then we have the silica nanoparticles. Okay. So from this, they are looking at next generation materials, and they have been outlined here, including the hybrid system, which is of great concern. So we can't speak about materials without looking at testing. So vertical flame test, limiting oxygen index, cone calorimetry tests, and then TGA are also being looked at, which has gradually advanced into SEM-TEM, SRD, Raman, and thermal mannequin testing, and then multi-scale modeling, to sensor integration, IoT connectivity, and then durability assessment. So the regulatory standards, we have the FAA FAR 25.853, which continues to update and then update itself with stricter heat release requirements. So the other regulatory standards have been listed here, the ISO standards and the military specs. Then regulatory alignment. In the early period, it was basic flame resistance focus. The middle period was smoke toxicity concerns. And then the recent is sustainability and smart integration. Sustainability has to do with biodegradable fire resistance textiles.
So you have 2 minutes.
All right, thank you. So we'll move from here to the conclusions. Sensor integrated smart textiles under extreme aerospace conditions. Some of the things that were looked at, and they have shown promising performance. And they also, under extreme aerospace conditions, their durability remains a concern. Smart fire resistance fabrics also present a leap forward in safety and monitoring for aviation crews. And then another conclusion has to do with the barriers to scaling graphene oxide and reinforced aramides. And the third one, for the future prospects of biodegradable fire resistance textiles, they've been outlined here. There should be research to demonstrate that such fibers can achieve moderate flame resistance when enhanced with phosphorus, nitrogen additives, or nanofillers. Recommendations: we need to invest more in graphene oxide research. GO kept popping within the research analysis, and then develop smart textile standards with regulatory framework, because it's a challenge. When you look at the challenges, it's one of them. Then strengthen international collaboration, especially Africa. We need to work more on technical textiles to solve some of the problems. Thank you.
Thank you. Thank you for your presentation. Please, a round of applause for her. So the floor is open for a few questions, and then we'll take the second presentation. Yes. Okay.
Okay, thank you very much. That's a nice presentation. And please, I would like to know, I don't know whether I'm the one who didn't hear that, but I didn't hear something about the day you queried the data. I mean, the time and date. So, I mean, the Scopus database and then the Web of Science. So I was expecting to see the dates, I mean, when it was queried. Because if you did your, I mean, search last year, the number of publications, of course, will increase. So I don't know whether...
Thank you for the question. It was sourced out around the 28th of October. Some were sourced out around the 28th of October. Sorry, August. August, sorry, thank you.
Okay, Miss Christine. Miss Christine.
Yes, please, I'm listening.
Okay, yeah, I saw you looking at that direction. I was surprised.
Sorry, I was signaling my roommates. Sorry.
Okay. I don't know, Doug, maybe I hope I stand to be corrected on this. It seems maybe there are certain things I just have to probably draw your attention to in your presentation, first of all, for my question. You were referring to Dr. Tiu's presentation alongside yours, which I think ethically you have to look at it next time, because the focus of his presentation was different from yours in that context, okay? And please, what's the difference between bibliometric studies and systematic review?
So thank you for the question. The systematic review has to do with following standard protocols like the Prisma flowchart to make sure that your review can be simulated. When they follow your process, the same thing can be done. And the bibliometric and the systematic are actually similar, but they are different because the bibliometric has to do with a wide range of, I don't know, correct me if I'm wrong, right?
Okay,
it has to do with a wide
you look
range
at
of
the
data. Okay.
Can you please take me to your methodology?
Methodology?
Yes, please. Yeah, there is the studies as well as the diagram presentation that you discussed, and most importantly, you are looking at your discussion or the findings that you made.
Okay.
It seems you are just giving statistical studies. For example, the countries that you projected that they recorded higher fire cases.
Yes.
Maybe I was expecting what was the possible reasons why those cases were recorded and the need for that country researching more in that area.
Please, are you talking about the 70 aviation crisis that way?
No, when you did your studies, the breakdown, talking about countries that are researching more into fire resistance.
Okay.
So what was the possible reasons why such countries are recording such cases and the reason why they also went into that kind of research? Since we are comparing it to Africa, for example.
Yes, actually, that is a very beautiful question. I think it has to do also with the geographical area. We all, as a global entity, experience aviation crisis. But the question is, what is our speciality? You know, over here, as textiles people, unless, forgive me if I'm wrong, but I've observed that for us to go into the technicalities and the sciences, most of us who do that, or most people, I'm excluded though, most people who do that are people who have had outside exposure. So over here, what we specialize in is in design. We also do a little of the sciences, but our course is textile design technology. So probably those countries are into textile science, textiles engineering, and textiles technology. And that is a gap that we need to look at as an institution. We should not focus only on the sciences, but we should also develop labs and focus on the engineering and then the technological aspects. Thank you.
Thank you. So I think 3 questions for her is enough because we have a couple of people who also have to present. So Christine, thank you very much.
Thank
I
you,
have a couple of other questions for you, but that one will be
all right.
One-on-one.
Thank
yes.
you.
Thank you. Thank you for your presentation. So we welcome the second presenter. And the person is presenting on wearable technologies in energy harvesting for sustainable power generation in smart textiles. Wearable technologies in energy for harvesting, for sustainable power generation in smart textiles. And our presenter is Mr. Emmanuel Danso. So, Mr. Danso, you would want to use your laptop, right? Hello, IT.
Good afternoon. I'm Emmanuel Danso. I'm here to present on wearable technologies in energy harvesting for sustainable power generation in smart textiles. Okay, so wearable textile electronics such as smart clothing, smart gloves, smart socks, and smart devices have evolved beyond aesthetics to provide dynamic functionalities, according to Tang et al. 2018. These devices can sense, respond, and adapt to internal and external stimuli for energy and information generation. These devices also provide flexibility and comfort by enabling real-time data access. When collaborated with the human body, they aid in cognition, activation, and seamless interaction. Integration of electronics into fabrics has led to lighter, more flexible, and powerful devices. Wearable textile electronics has contributed to health monitoring for checking vital signs such as the pulse, electrocardiogram, and also oxygen saturation in the health sector. Current reliance on batteries limits their lifespan and also flexibility, which also poses risks of leakage and fire. Energy harvesting from body heat, motion, and environment offers a sustainable alternative. There is a company in the UK which is using human footsteps to generate electricity as an alternative for batteries, and this can be applied in wearable textiles. Please, can you play the video for us?
Energy from people's footsteps. Every time people walk, our technology captures their kinetic energy and turns it into electricity. The more people walk, the more power we can create. We've got operations in about 9 countries at the moment. We've installed about 200 sites around the world. So that goes as far as in Korea, we're powering Kia motor factories. We're also in Nigeria powering soccer pitches. Rio de Janeiro, we've been working on a number of public infrastructure projects there. And recently, the US has been huge for us. We've got a great saturation globally, and now it's about focusing on the core verticals that are going to give us growth.
It's not just about power, is it? You've got a whole thinking about how it generates power, data, and engagement as well.
Yeah, so I think the energy space is really tough, and we know that. So we have an energy source, it's an off-grid power. So for example, one footstep will give you about 20 seconds of light on an LED fitment. But what it does as well is we're producing data. So for retailers, it's heat mapping, it's knowing where people are. For municipalities and transport sites. But we've also got a way to connect it to your mobile devices. So I actually know who you are walking into a space, and we've got a reward mechanic based on how many steps you make. So if you make 50 steps, we'll actually give you a financial equivalent for the steps you're making in that environment.
Okay, so the methodology used for this project was an integrated review approach, which combines the quantitative, qualitative, the systematic approach, and also peer review approach to discuss broad topics in all the areas. So data was sourced from the Scopus online database with these keywords. So we have the wearable technology, wearable devices, and others. And we went ahead to discuss the contributing countries, and also the publication trend. So with the contributing countries, we have China leading, followed by the United States of America, the United Kingdom, India, South Korea, Singapore, Hong Kong. Voice viewer software. So the voice viewer software help us to analyze some of the keywords in wearable textile electronics. So the minimum number of occurrence were the keywords were set to 5, and the minimum number of occurrence were 5. So keywords meeting the threshold were 183 with 7 clusters, and total links of 6,001 with total link strength of 15,695. The first keyword we analyzed was smart textiles, and it had 227 number of occurrences with total links of 182 and total link strength of 202,141. The next keyword we analyzed using the Scopus, using the voice viewer software was nano generators. It also had 150 number of occurrences with total links of 180 and total link strength of 1,452. Now, renewable energy harvesting mostly rely on thermoelectric, piezoelectric, photovoltaic, and the triboelectric energy system, alongside with the electromagnetic harvesters. And these techniques offer unique benefits and limitations, and it is recommended that hybrid approaches, that is combination of the thermoelectric, the piezoelectric, and also the triboelectric, can help provide sustainable power generation in smart textiles. This diagram here is an illustration of the various harvesting techniques, and it was inspired by Tang et al. 2018. So we have the photovoltaic, the electromagnetic, thermoelectric, and also the piezoelectric and the triboelectric. And these devices has a power generation or a power unit that are being connected to a sensor, which process it and also communicate in a form of electricity. And these are also an illustration. So with the thermoelectric, it converts body heat into electricity using the temperature differences. And the piezoelectric also generates power from body motions using vibration or pressure. The triboelectric produces energy from friction or contact between materials. Then the thermomagnetic captures energy from large body motions via magnetic induction And the radio frequency also collects ambient wireless signals to power ultra-low energy devices, as well as biofuel cells, which also convert biochemical reactions such as sweat and enzymes for electricity. Integration of energy harvesting storage. So when these devices are being integrated into wearable textiles, they help store harvested energy for a continuous power supply by enabling self-charging textiles that combine harvesting. And also, they provide device reliability during periods of low energy. And they also help maintain the flexibility, comfort, and washability of the garments. The benefits. When these devices are being integrated in wearables, they reduce the dependency on batteries, that is enabling continuous maintenance-free power for smart textiles. And these systems also enhance the durability and comfort while supporting critical application in sport, military, and also our everyday life.
So Mr. Kwame, so you have 1 minute.
In terms of performance, they are flexible, washable, efficiency, and also user experience. So it gives seamless integration into daily wear with minimal disruption. They can be applied in health monitoring, sport and fitness, industrial work gear, military and defense, smart fashion, and consumer electronics. Challenges and research gaps. So they are, in terms of scalability and mass production, there are difficulty in large-scale, cost-effective manufacturing. And also, it lacks universal protocols for performance evaluation and ensuring washability, flexibility, and long-term stability. Environmental impact, that is concerns about material sustainability and end-of-life disposal is also an issue. Future direction. Since the world is advancing in Internet of Things and artificial intelligence, these devices can be integrated into textile to give real-time data analysis and connectivity. And bio-inspired and self-healing materials can also enhance durability, sustainability, and adaptability. And the hybrid systems can be combined to provide stable and efficient power for wearables. Machine learning in design can also help optimize the textile structures and predict performance.
You should
in
be
conclusion,
concluding. Thank you. Thank you. Go ahead. Go ahead.
In conclusion, energy harvesting, interdisciplinary collaboration is essential to achieve commercial viability and environmental sustainability. Thank you.
Thank you very much for your presentation. And now we take a few questions. So we take three questions, and 1 question per person, please.
Mr. Danso, that was a very good attempt, because the key words that you have made mention of wasn't easy listening to you with the triloba and all that, no thermos.
Triboelectric.
Yes, it is well. Okay. Please, I think maybe from the background of what you presented, in your own prospective analysis, what would be the feasibility of this technology in the sustainability of the textile industry and to an extent the Ghanaian textile industry?
Please, the question again, please.
Okay. So in your own inductive analysis or prospective analysis, what would be the sustainability of this technology in the sustainability of the textile industry and to an extent the Ghanaian textile industry?
Okay, thank you so much for the question. So whilst the world is advancing in technology, the focus is not on the designs we are making in terms of textiles, but then we should also look forward in inculcating or integrating technology into our curriculum. So this will also help us compete with the world. And in terms of sustainability, it will help in a way that it will help in a way that it will help in a way that we can also produce things, because if you look at the presentation that Mr. Dr. Hughes gave, we have smart socks which prevent you from falling, old age from falling. So these things can help, because if maybe my grandma is in the house and she's using stick to walk, the moment she sleeps, she will fall. But wearing this kind of socks will prevent her from what? Falling. So I think that is the least I can say.
Yeah.
We have a question and then feedback from his mentor, and then we take one from co-author, and then we take one from Timothy.
Thank you so much. I really like the exuberance in you. As a young man, I was chatting with my colleague here. So keep it up. But from my observation, I realized what you presented was basically scientific.
Yes, please.
I don't know whether you are doing science at your university, because all the samples and the technology you have mentioned was scientific. What is the background? And what motivates you to look into this topic? Thank you.
Okay, thank you so much for the question. Okay, so last year I came to do presentation, and the panel was asking, so in the crowd, so this time around I decided to change my ways. So whilst the world is advancing, it's not about always sewing and also putting the colors on the fabric to change their aesthetics. But then we also have to look at other approaches, as in integrating them and giving different functionalities and also dynamics. So what motivated me is that I want to look into smart devices and also smart textiles. My co-authors.
Okay, so my name is George, and I'm the co-author. So it is all about, to answer the first question, for example, I'll start from the first question. The sustainability aspect of this work is that, you see, now we are trying to do away with things that are causing environmental harm. For example, if I'm using smart textiles, do I need to put on, or do I need to fuse in a battery or any other external thing that will end up causing an issue to the environment? So that is all about this paper. We are trying to look at how we can sustainably generate electricity or energy to be able to power smart textiles. So when we talk about triboelectric nanogenerators, piezoelectric nanogenerators, they are ways of gathering energy from the sun, from pressure, and also from sustainable resources. Thank you very much.
So in essence, they are saying by walking in my trousers, I should be able to generate energy that should charge my phone.
Yes.
Because it's a movement. Okay, once I'm doing a movement, I should be able to generate some form of energy that will help me power certain things. And so, Prof.
Okay, thank you. Dr. Crenshaw. Good. Well, GTech professor. Okay. Thank you for the presentation. I listened to the first presenter, and I've listened to yours as well. And it's exciting to know the advances in these technologies. But I want you to connect to hope. In your research and what you sought to do, what locally, what attempts are we making locally to also move on that same train or tangent? I think there's a critical review or so. So how do you connect your work to basic things we need to start doing as a country, and where has it started locally? That's my question.
Okay. Okay. So my mentor will speak then.
So his mentor will answer that.
Okay, so thank you for that question. So this question brings us to the fact that it's very important we do collaborations. I mean, in Ghana here, getting laboratories, equipment to go about these things, although we are generating the source from sun and the available materials, but then it's very important we do collaborations in order to be able to come up with this. So for now, the best thing that we are doing locally to talk about this or to explore this is through our research. So from the theoretical aspect and then collaborating with international researchers, we are trying to start such research or works. And then we know very soon some of these works will be seen in Ghana. So we are starting from the theoretical aspect through research, and we know this is going to be implemented. Thank you.
Thank you. Prof says the theories are too many. However, we have to start from somewhere, and I believe getting the knowledge is a matter of time. We'll start applying it, because application of knowledge leads to wisdom. Knowledge pops up, and we don't want to have the knowledge, and we look puff up. Okay, so we would apply. Fortunately, we have a couple of people in the system who have got opportunity to study outside, and they know some of these things. The only problem, like you mentioned, is how to do it, because we don't have what it takes to do it. So collaboration is the way to go. So our big bosses, our big mamas, when our boys come around, that you give them the opportunity to collaborate, work with people outside. Please grant them the letters, let them go and acquire the knowledge and come back. We'll take a brief input from our mommy.
Hello.
Hi.
Very well done.
Thank you.
I'm coming from industry, and I wish that your presentations will link academia with industry and the practical or application of the researches that you do. That will help us in the industry a lot. But you've done well.
Thank you. Thank you.
Thank you. Thank you for your beautiful presentation, and you may take your seat. So this is a first degree student, and I mean he's doing this. It tells you the capability. Okay. Our next presentation. And can you leave a laptop for us? We take our next presentation, and we are looking at the interplay of fashion material and structures in shaping garment, form, and function. And here we have Eugene Asamoah Redu to do the presentation. So Eugene, if you are here, please mount the podium and let's have your presentation. Eugene is not around. So our next presenter, since we are talking about sustainability, he is looking at optimizing vat dyeing performance for improved color fastness. Optimizing vat dyeing performance for improved hardness, improving circular color fastness. And so we take that from Mr. Edward Appel. Benjamin Addo. So Benjamin Addo will be doing that presentation. You also present with your laptop. All right. Okay. Close. All right. So you have 10 minutes, please.
All right. Good morning. Good afternoon, sorry. I'm Benjamin Ado, and then I'm presenting on optimizing VAT dyeing performance for improved color fastness. So our presentation outline, first we'll walk through the introduction, the research methodology, the experimental results, the discussion, and then finally we end at the references. First, so we know that commonly used dye in our textile industry by SMEs and artisans is VAT dyeing. And then it's commonly used with cotton fabric, which is commonly used. And then so we asked ourselves, we always stick to this common ratio, which is the 1:1, 1:2:2 ratio, which has to do with the dye is to the auxiliaries, which is caustic soda and then the sodium hydrosulfide. So what actually brought us, or actually queried us to do this research was, okay, so what happens if these auxiliaries are varied, or these ratios are varied? Do we get a different output, or it still remains the same? So that's what motivated us to actually do this research. All right. So we move on to the methodology. The study adopted is an experimental factorial design, whereby we used cotton, as I stated earlier, and then after that we tested all our substrates. After the ratios were varied across 21 samples, 9 with each color. We used 3 colors, which is golden yellow, red, and then violet. After dyeing with different ratios, we actually tested them out in the Textiles lab at the KUST, which we tested for the rubbing fastness, both on dry and then wet, using the croc meter machine. And then finally, we did a washing fastness test. And then after doing all these tests, and then getting the output from the fastness test, we actually graded them according to the grayscale standard. Yeah. So, our primary variable was the tweaking of the ratios, and so we moved on to our secondary variable. Our secondary variable actually dealt with the sequence at which we will mix the auxiliaries. And so first we adopted 3 sequences, whereby each first sequence, the dye will be placed in first, the next one, the hydros will go first, and then the third one, the sodium hydrosulfide will go next. So it has to do with, the approach has to do with mixing the dye, the sodium hydroxide, and then the sodium sulfite. And then we also controlled the fabric, the dye bath concentration, which was 300 ml. The exhaustion time was timed, and then we had a timed oxidation time for all the 21 samples, which actually resulted in the color fastness, led us onto our research. Now, the parameters used, we actually used a half teaspoon as our measuring tool, and then the fabric size for each sample was an A5 size. The concentration used was 300 ml, and then the exhaustion time was 3 minutes, oxidation time 5 minutes. And then our mixing sequence, as I stated earlier, we had for the golden yellow, we had the dye going in first. But then with this one, we also did another small tweaking with it, whereby we actually questioned, so what if we actually mix these auxiliaries separately and then add them? Does it have any effect on the final output? And so we also did that. Now we move on. Some tools, the tools we used during for the research, our testing was, and then the whole testing was, we used the metric measuring tool, which was a teaspoon I stated earlier. We had some stirring rolls, beakers, test tubes, and then dyeing bowls. The materials used was the mercerized cotton, which was, we actually used that because it's the commonly used fabric by artisans, local artisans, and then for who utilizes VAT dyeing technique. Caustic soda, and then hydros. Now the testing equipment used, we had a croc meter, which actually helped us test for the rubbing fastness. We had a color precision reader, which actually calibrated the local, the overall color readings of the samples. And then we had a matching cabinet, which was used alongside the standard grayscale, the I05, A05 grayscale. So these are illustrations of the first one is the clock meter, the middle one is the Amstat, which is the precise color reader, and then the cabinet is the next one with the grayscale, which is used for the grayscaling. So I'll go back. As I stated earlier, we had our sequences, and so each color had a sequence which it followed. The first one used the CHD, which the C stands for the D stands for the dye, the C stands for the caustic soda, and then the H stands for the sodium hydrosulfide. Now we had 9 dye baths for each sample. We had 9 dye baths for each color, meaning each sample was dyed in a different dye bath with different ratios. We had our ratios, and then we moved on. So these are the ratios we used. So the golden yellow has different ratios, but then we also wanted to have something which will test all the ratios against. So we used the conventional ratio, which I stated earlier, which is the 1:2:2, against all the other ratios we generated to see if there will be variations, because we didn't have anything to compare it to if we had to actually say that we actually try to get distinctions between everything. So we used, each color used the conventional ratio, which is the 1:2:2. And then, but then the mode of mixing and then the mixing sequence was varied. So these are the ratios we used. Moving on, our experimental results. These are the samples we had. We had 9 samples for each color, and then to its right, the left, the one on the left, it's the original dye sample, and then the right is its color output after using the precise color reader to actually copy the overall color of the samples. Doing the fastness, we checked whether, okay, so when it's wet, and then let's say it is rubbed, does the color actually fuse off or it doesn't? And then we saw that it had a very good a very great dry property, and then a very abysmal wet property, because most of the calibrated grayscalings for the dry was more about in the range of 4 to 5 and then 5, and then most of the wet went down to the extreme of going to 1, and then had some 3s commonly and 2s in it. This was for the violet samples we also dyed, which is 9 in total, and then to its right is the digital calibration of its color. We also did the rubbing fastness for that samples too, and then we realized that it also had a very good dry fastness property, but then when it comes to its rubbing fastness, it's performed abysmally with low numbers up to 1.5 and all that. So discussion of our research, as I stated earlier, we wanted to check if these ratios are varied. Does it actually have any effect on the substrate, the final product? And so what we did was that we actually checked through our ratios to take ratios that had more hydrosulfide, ratios that had more sodium hydroxide, and then we used them to check, compare them to the conventional one, if there's been any improvement or it's still not doing anything better. So the first one was the effect of sodium hydroxide on the rubbing fastness. And then we did that. We checked for the difference too. We checked for ratios which had difference 2 compared to the hydros. And then we had a 4:2:3 ratios. We had a 5:1. And then we compared its rubbing fastness to the the standard or the conventional ratio that's being used. And then we realized that when it comes to dry fastness, the ratios with more hydrosulfite was performing better than the conventional ones. But then when it comes to weight, it was only one sample which performed abysmally. And preferably, that means that most of the samples that had more hydrosulfite performed better than the conventional ratio. And then we moved on. So there's a discussion which increasing sodium have improved dry and wet rubbing fastness with performance of 5:1, and then, yeah. So we moved on to the effect of sodium hydroxide on rubbing fastness. Here also we realized that only two of the ratios we actually used to tally it against the conventional one did well. And then when it comes to wet rubbing fastness, it's performed same as the conventional ratio, which we actually used it against. But then the dry fastness performed very well, more than the conventional ratios. Next is we also used we also checked a balanced ratio of sodium hydroxide and sodium hydrosulfite against the conventional ratio, which is the 1:2:2, to check if sodium hydrosulfite and sodium hydroxide are used equally. Does it also have any effect, or does it perform well more than the conventional ratio sample? And then we realized that yes, indeed, it does, because after analyzing, we saw that the ratios two had a very good dry fastness property and then good wet fastness property compared to the conventional one. But then the middle, the second sample, which was tested against the first one, performed
you have 1 minute.
Abysmally. All right, so we move on to key findings. Sodium hydrosulfite alone. Conclude. All right. So our study demonstrated that sodium hydrosulfite dosage strongly influences rubbing fastness. Also, sodium hydroxide concentration affects diffusion, and a balanced combination of sodium hydrosulfite and sodium hydroxide, the most consistent and sustainable resource, with ratios 1:1:5 and then 2:1:1, achieving the best dry and then wet fastness grades. Overall, the findings confirm that controlled reagents optimization enhances dye fiber bonding, improves color fastness, and reduces the risk of wasteful overdosing. This optimization pathway provides a scientifically sound and environmentally conscious strategy for advancing sustainable VAT dyeing practices in the textile industry.
Thank you. Thank you for your presentation. Yes, so he's in third year, now going to final year, KNUST. And so it's a beautiful presentation because we are looking at sustainable future. And here he is trying to optimize. You know, we don't want to just die. We want to have the best conditions so that we don't waste, we don't produce a lot of waste. So this is very good experimental lab work, and he did it in our, ongoing KNUST lab. Yes, so he did it in our well-established lab. We are still finishing anyway. So we take questions. However, before we take the questions, I wish to remind you quickly that this evening we are having a fashion show gala for the tertiary institutions that are present here, and we'll be having it at the Faculty of Applied Arts. So please, this evening at 6 p.m. please come and feed your eyes with something good. And so we take questions, and Ni, I'll come to you. Let me take.
Yes, thank you very much. Very good presentation. I just want to ask this. The various samples that you took for and the various ratios you use for the dyeing, I just want to know the precision level. What did you use for the measurement of the dyes? Was it spoon or how? What was the precision level of the various samples that you took?
Yes.
Please, I'll designate that question to my co-author, which is...
So, co-author, sure that the quantities you took are exact and accurate.
Yeah, Prof, thank you. We did a controlled experiment, as you said. I was expecting you to take you to the, what do you call it, the methodology. Everything is spelled out there, the measuring system for the control environment. So with the independent variables and then the secondary variables were all spelled out. So we use a metric system of half teaspoon measurement for the dye and the caustic respectively. Thank you. That was what we also testing that theory to confirm whether that 1:2:2. That has been a traditional norm or maybe theory of dyeing. It has been there. For example, unless otherwise, maybe open up, we are professionals here, Prof. So the 1:2:2 has been the studio-based ratio. That, no, is any time, for example, yes, but we have not been established theoretically that who is the author of that theory. Okay, Prof.
All right. So there's a question.
But Prof, a very quick one here. I do remember that during one of our design thinking class, you mentioned that sometimes these things are not theoretically backed up, but then they are, but there are certain things that culturally we all know that does it. So probably that's the angle he's coming from. Okay, thank you very much. To my question, please. During your presentation, right, you asked a rhetorical question, right? A rhetorical question, and you were wondering that mixing the chemicals together, the chemicals separately from the dyes, and then combining it, and then also mixing all together, there might be some effect also. But I didn't hear you reporting on that, so I'm interested in that. Thank you very much.
So, will you like to answer, or you want your co-author to take care of that?
I'll still need that.
Thank you, Senior. That's something, of course, is in the findings, but because he skipped, that was a problem. So that was a secondary variable we considered in the experiment, secondary variable. Because we're looking at, in the conventional mixing sequence, probably you have your water quantity, then you probably bring the dye, the hydros, and the caustic. So we decided to vary the mixing sequence. What about if you start with the hydros, caustic, and the dye comes first? Does it have any adverse effect on the color fastness? And then we mix them separately and brought them together as one solution to find out. So we realized that there was marginal or minimal effect of that mixing sequence on the color fastness. So that has been established to the fact that it doesn't matter how you mix these chemicals in bad dyeing, it does not affect the color fastness. And that was in the key findings, but unfortunately, he was skipped in that sense because of time.
All right, so we have questions from our online audience. And so, Raphael, we take your question.
Okay, yeah, thank you very much, Doc. Okay, so my question is on the issue about temperature, pre-treatment, and conditioning can also affect the eventual quality of the color on the fabric. So, did you have any temperature set for the water, and then did you pre-treat the cotton fabrics?
Yes. So, will you take it?
No.
Dr. Rao, thank you for your question. Unfortunately, that was not considered as part of the variable of the study, so we didn't do that kind of consideration. Thank you.
So fundamentally, you are the factory hand and he is the head. Yes.
So thank you very much. I think Dr. Siru has already mentioned the part of my question. My question is going to be how internationally, when it comes to scalability, how is it going to be possible? Because the condition in Ghana here is totally different from any other. So how, in your research, did you come across or did you try addressing that? Thank you.
Ben, would you like to answer that?
I'll take the last one.
Okay, that's good.
Okay, so we have one more person waiting online. Isaac, can you hear her, please? We
yes,
want
I
to
can
take
hear
the
you.
question.
So my question is, how significant is this research to the local dyeing industry?
How significant is this research to the local dye industry?
So local dyeing.
All right, so I'll take that question. So as I stated earlier, the whole research actually held from asking what if this conventional ratio local artisans used, which we actually came to meet, alters or changes, what effect? And so I think from our study and then our results, I think it will benefit them in a way that if references are made to our ratios, they, for instance, they can actually aim or get a precise color or a shade from the ratios we actually improvised or used. And then it will actually help them, or it will guide them. And I think local artisans wouldn't have the time to actually test for this thing, but we actually did, and then they will know that, oh, if I take this ratio, I'll have this kind of effect as in when it comes to rubbing fastness and then its grayscale values. Yeah.
Good afternoon.
Okay, that's fine.
My name is Sherry Otami. I want to suggest that next time you don't use a spoon for your measurement, because the half can be hip at a time, and at another time it can reduce. So you might not get it right. So next time you use the scale to do it. Thank you.
Yes, so in the lab we have weighing scale, and so we typically don't recommend spoon because, you know, 1 teaspoon, half teaspoon, we don't recommend that. We ask that you use a scale to do that. Yes, so we take our last question, and then we take our last online presentation for this section.
Yeah, thank you very much. I think it was a very good presentation, but my issue is that manipulating the chemicals, did you also check the strength? Does it have any effect on the strength of the textile material? Because you know when you expose the textile material to chemicals, it has some level of degradation. So did you check that, or you were just interested in the effect of the color?
Yeah.
Because that one should also be taken into consideration.
Okay. So please.
Yes.
Yeah.
Increasing the caustic soda. Yes.
Yeah. So we actually didn't aim at getting the, but then we are still working on improvising our textiles lab, and then I think at the right time we have machines that will help us do that test, as in checking the strength of the fabric. After the
Yes, and my last issue is that when you started, you said the 122 has no theoretical base.
Yes.
So at the end of your research, are you prescribing something that is good for the local textile industry, like the tie and dye batik industry?
I'll actually not chase that question out to my quota.
Quota.
Okay, Celia, thank you very much. First of all, we wanted to establish that theory, why that 1:2 in conventional dyeing, which of course we are looking at the hydrous as a reducing agent and then the caustic as the alkaline agent that facilitate the dyeing process. So we realize that as our findings concluded, when you balance these two chemicals, so to speak, it gives or contributes to the color fastness property of it. So in so doing, we are trying to establish that yes, that's the more reason why technically the 1:2 has stayed over some time. And that the theory behind it is that if you are able to balance these chemicals in the dyeing process, it will give you a good color fastness property. So any of these ratios, so to speak, or any of this theory, as far as balancing these two chemicals is concerned, will help you achieve a good color fastness property. I think maybe that will be for future research. That will be for future research. Thank you very much.
Yeah, so I would say it's an ongoing work, and he would complete, and I'm sure in one of our conferences he would come and finish the presentation. All right, so on this note, we take our last presenter who is online, and the person is presenting on innovative practice-based textile recycling, techniques and insights from Reclaim Textile Network, Ghana. And this one is supposed to be part of session 3, but because they don't have the online facility, and so we are bringing the person here. And the presenter is Sylvia Jampo. So Sylvia Jampo, if you are online, I'm looking forward to your presentation. Thank you.
Thank you very much.
Yeah, kindly share your slides. Thank you. We can see it.
So I'm presenting on a practice-based textile recycling for sustainable fashion and community empowerment in Ghana.
Yeah, please go ahead.
Thank you. Yes. So as we are aware, the global textile waste crisis is being driven by fast fashion and second-hand imports as well. And unfortunately for us, our Kantamanto market in Accra has been recorded as one of the world's most largest importers of used clothing, and then creating a lot of waste and also creating a lot of floods, landfills, and health hazards as well. So the Reclaim Textile Network Ghana, which was launched recently in Accra, is offering a community-driven recycling solution. And that is what this paper aimed at, focusing the techniques that was adopted here and was captured in this paper, and highlighting how it is empowering communities as well. So this Reclaim Textile Networks initiative is a community-driven response that is serving as a solution to these menace that is coming up. And in this era where we are all driving a force for sustainability, this has become essential to capture and take attention as well. We also saw that few sustainable recycle initiatives have been well structured and documented, especially in our part of the world. And there is limited study on a practice-based recycling approach, and most especially a grassroots recycling, that is with the masses, the people in the masses, and as in people in the grassroots taking practical initiatives in recycling in the African context. So there is limited research in this area, and that is what moved us for this research. So we saw that in terms of gap, we saw that there's a limited evidence in linking recycling to skills building and empowerment. So there is a need to document an indigenous and a low-costing recycling models that will help bridge this gap and also advance sustainability as well. So there is an importance of linking theory to practice and community diffusion that will help achieve the sustainability agenda we want to accomplish. So the theoretical framework that guided this study was through an experiential learning approach where participants were engaged through this cycle framework where there was a concrete experience from participants participating in the recycling process. And also reflective observation where participants observed and reflected upon means and approaches they will use to join up pieces of fabric to produce something to reduce waste. So there was an abstract conceptualization as well, where ideas were developed and then especially those in the university formal session, also did digital illustrations of their work and then proceeded to an active experimentation where they tried their hands on and then to produce tangible materials as a means of textile waste recycling. So this study was guided by an experiential learning theory, together with the diffusion of innovation theory, where we adopted the perceived characteristics of this diffusion of innovation, where we looked at relative advantage, compactability, complexity, observation, and traceability. Then, for our conceptual framework, that was what we got out of these two theories. We saw an integration of experiential learning and diffusion of innovation, where we saw textile recycling waste as a learning process and an innovation pathway. So we saw that there is a means of education and empowerment as well. And then it can serve as community when it is adopted in the community. It can yield sustainable behavior. It can improve sustainable behavior, and then there will be entrepreneurial opportunities, which we even have testimonials to that, and cultural aesthetics that comes to Ghanaian cultural aesthetics. So we are going to see more of that in our work. So the paper sought to document innovative, low-cost textile recycling techniques as well, and as well as to assess practice-based learning improve participant skills, to improve participant skills, and also to explore potentials for grassroots recycling as a catalyst for sustainable fashion and empowerment as well. So our methodology was, our research philosophy looked at the interpretivist, and then the research design was purely qualitative, which is a practice-based design process that was compatible with it. And then it was a multi-case study. So the whole sampling technique was purposive. We looked at 6 senior high schools and 4 higher educational institutions, 2 churches, and 1 rehabilitation center. So in all, we had about 100 participants, ranging from students, teachers, community members, and the rehabilitation trainees, with the age range of 15 to 40 years, balanced male, female, averagely. So our data collection techniques was through a semi-structured interview and then an iterative design experimentation for feedback as well, where we use some thematic analysis. We did some thematic analysis here. So for reliability, we did some member checking and triangulation to make sure that, to validate our research. So the outcome or the results of our research, we saw that we were able to document innovative, low-cost textile recycling other than very expensive textile recycling machineries that have been advocated for. These are very low-cost ones we saw feasible from the grassroots level. That is a modular patching for garments and upholstery, then buyer strip weaving as well for mats and accessories, then hand staffing for racks, hybrid applique for deco and then surfaces, fabric knotting, and then pattern freehand garment construction. So one of the testimonials we had from the rehabilitation center was experimenting with patchwork and staffing. The participant said that experimenting with this patchwork and staffing has shown her that fabric waste is not just a waste. and it can be turned into a new design. And they were excited about that. So these are some of the results of the findings. Pictorial evidence. So that's a church grouping, and then the institutions as well, from Accra Technical University, and then a church group up there. And we also have students from Asanska also producing, and Radford University as well. Then we have the senior high students who were very much happy about this whole process of they able to stitch up and produce something from waste. So waste is no more waste, but it is a treasure that we can hold up to. So these are some of the final products that came up, samples that was produced. So practice-based learning, we saw that this practice-based learning can be a source of skills development as well through stitching and the fabric manipulation. And one testimonial from a senior high student was that I never thought I could stitch anything, but now I can confidently produce an item, and I'm proud of that. So, and then also for empowerment, for sustainable fashion and empowerment, we saw that the women in the rehabilitation centers also were able to diffuse some skills in this research. So they were able to diffuse some skills. So, and they were also empowered to also start selling some stuff that they were able to produce by themselves.
So your time is up, so kindly try and conclude.
Okay, so in effect, the aim of the research, that is documenting low-cost recycling techniques, was fully achieved. And then we saw that, yes, these recycling techniques can really unleash creative skills as well, and inspire entrepreneurial interest, and also grassroots empowerment as a form of an educational reform. So this was what was achieved in this research. Thank you.
Thank you very much for your presentation. Yes, so we have a few questions for you, but we are going to start from our online guest. You can see Raphael Kanyere Sedu is online, and his hand is up. So please, let's take your question.
All right. Yeah, thank you very much. What is the difference between recycling and upcycling? Did your work do recycling, or it's actually looking at upcycling?
Yes.
Okay. Upcycling has to do with when you take an existing product and you make it better, that you upcycle it. And there is also downcycling, where you lower it and it still can be used, upcycling. But this one, we're talking about recycling techniques. So there was nothing like a product where the fabric was faded and we upcycled it to improve it. But this time we talked about, we looked at the pieces of fabrics that were going to go with, and they were stuffed together to produce another product, either a garment or doormat. So we actually reproduced. But upcycling, you build up, you improve on something like a faded jeans. So you improve upon it, and use it, the material, as a tote bag. So in that case, you have done that. So our research did not cover that as well, but we looked at recycling techniques that we can document and also empowerment from the grassroots.
I would suggest you rather go with upcycling because your work is talking about upcycling. Because in recycling, you definitely will have to break down the textile material into an element before you now start rebuilding into something different. But upcycling, you don't really need to break down the material into a simple element before you use it. That is why in upcycling, you simply just get it and then you cut it, and then either you use quilting or all those other methods to actually join the fabric, join the pieces to actually produce your end product. So I would suggest you go with upcycling because it is more towards that end goal. And then you looked at 100 participants, right, using a qualitative approach. That's quite a huge number for qualitative research. What software did you actually use in data analysis? Because you are dealing with larger numbers. How were you able to analyze such 100 participants' responses?
Okay, so this was actually a practice-based research where Textile Reclaim Network organized workshops and through it before its launching, the launching of the NGO. So this had a participants from different institutions and 2 churches, and so it was not like a one-time getting all of them on board for this. So at the end of the day, we cross-checked by making sure that we are observing them doing it. That is why I talked about member checking. Yes, so, and then we analyzed our data through a thematic analysis. Yes, so that is what.
All right, so again, is it a longitudinal study or what is it? Because if you say you did it over time, then is it a longitudinal one or is just, a one-time putting people together and taking the data? And what it means is that the numbers will still be too great to be able to have a qualitative insight. So what is it exactly? Did you get a question, please?
Okay. Yes, please. So it was a longitudinal study that followed the same participants or group of people over a time, and we collected these waste pieces of fabrics. Some of them we actually dismantled the yarns out, brought them down. So we were doing a kind of a low cost kind of recycling, not an advanced one where we will need larger equipment.
Thank you. Yes, so kindly consider your numbers. So we take one more question from Dr. Boama, and then we go to our online guest.
Okay, thank you very much. Please, in your presentation, I heard words like waste. And would you agree with me that the use of using waste into other products will affect people's patronage of the product? Looking at our settings, our perception about waste, if it is going to be something that is going to be worn, isn't it going to affect people's patronage? Isn't there a better word? I think there have been research into certain words, using certain words other than waste. So my question is, wouldn't it affect people's patronage of whatever products that you have done, instead of maybe the innovation that you think you have come about? Thank you.
Thank you. So will you like to respond?
Hello.
Or you take the next question and then before you respond?
Dr. Christiana would like to come.
Okay, Dr. Christiana, let's hear you.
Right. I think that the right word is textile cutoffs. Textile cutoffs instead of the waste. But just to make people understand what actually the raw material is. That is the reason why we use the waste. But the better word is the textile cut-offs. It's fresh. We take them fresh from the fashion designers.
Okay.
So thank you for that information. Thank you
All
very
right.
much.
So I think your presentation is interesting. You have a lot of questions. And Isaac Abraham, we'll take your question.
Yes, I'm on. Okay. So I want to find out the novelty in this research. You said you are looking at indigenous recycling or traditional recycling. I know people have attempted lots of these recycling, like doormats, clothing, patchworks, and other things. What is so unique about your this particular research as far as recycling is concerned? Because you mentioned that there's limited study on this.
Please.
And I know that people have really attempted this particular.
Hello.
Yes, go ahead.
Yes, please. What is unique about ours is that we are a whole number of individuals. We are usefulness of the textile cut-offs, going to churches, the rehabilitation centers, and a whole lot. So that is making out they are doing it on their own. So we are advocating on a wider platform, and it's yielding a whole lot of results. People are now getting job to do, and that is the novelty of our research. Thank you.
Thank you very much.
And I'd like to add up that this is also one of its kind paper that is showing that grassroots empowerment through this research, as in textile recycling, can empower people. Yes, so as the government is thinking, initiating ways of empowering people, women and children and all that, this paper is bringing a novelty that there can be empowerment through recycling as well. Thank you.
So it means that you are looking at corporate recycling. Is that what you're looking at? Not just the end product, but the corporates.
Yes.
Both of them, please.
In effect, fundamentally, yes. So it's not just encouraging individuals to do it, but how can groups do it? So we take our last question.
All right, thank you very much. I think, may I ask you whether you did some practice as a result of these findings? Or this is just a mere theory? If you did, you should have seen what you have done through the upcycling to appreciate your work very well.
Oh, hello.
Yes, we can hear you, please.
Yes, please. We did practice, actual practice. We went to the schools. I think we have shown a whole number of pictures where you've seen us inside the picture, helping people to come out with their presenter can scroll down the pictures. We did something like that, a whole lot, and we have tangible evidence. Even here in Accra Technical University, students who we help or we sponsored, they use the textile carton. They didn't buy any material. And at the end of the day, 2 students from our side emerged the best winners. Radford University, they use the textile carton for their final work, as well as Asanska University. So it is practice-based. Thank you very much.
All right, so there's a question you don't need to answer, and then we'll go for break. Thank you.
Okay.
Madam Christie, thank you for your presentation. Or it's Sylvia. Please, this question is for digestion. Please don't answer, I beg. Otherwise, trouble for here. You are going for lunch break. Please, what was the justification for the theories that you adapted for your study, and how did it inform your conceptual framework? Thank you. For digestion, please. Dr. T, please, I'm done. Okay, someone wants to ask digestive question.
So mine is, how did your worldview also influence the work? Because we saw some interpretism as a worldview that you applied in the work.
So that's too you don't need to answer. You just have to think about it. And then there was a question from there. Somebody was asking that you said you use practice-led, right? Meanwhile, according to your presentation, you said you went to the schools and then you taught them to do it and then they did it. And so how did that become practice-led? You don't need to answer. Thank you. Practice-based. Thank you. Thank you very much. You don't need to answer. At this moment, we go for break and we are going for our lunch. For the lunch? Yes. And so another advice, you don't need to respond. Work on your images. Thank you very much. And so we are going to the Faculty of Arts. When you step out, we have people who direct you right there to take your lunch. And then at 2 p.m. exactly, we come back to continue with the rest. Meanwhile, be reminded that this evening, 6 p.m., we have Fashion Show Gala.
beginning, I think the idea started late last year when I was teaching some fashion design students. So basically, I would say to give a background to this study or to this project is that we've seen how AI has been impacting the sector, especially the creative arts, where we've got new AI platforms that are allowing people all over the world to do their designs using various prompts to come up with the ideas that they can now maybe edit or maybe present them as their own original ideas. So you'd find that in class, students who are doing fashion design, not to say it's the only area, even industrial design, fashion design, jewelry design, product design, etc., we are saying students are finding these AI tools useful to them, but there is a problem where we say in terms of curriculum development, to what extent is the relationship between the instructor and the student smoothened out in terms of the use of AI in terms of creating their products? Because in the design area, it's much more of design and illustration and coming up with an innovative idea. But then we've seen new trends coming up where students use various tools which are technologically advanced to make sure that they either fulfill their assignments or they fulfill their capstone projects. So the presentation is going to follow like this: the introduction, the review of our literature, the methods that were used, the results, the discussion, and finally the conclusion. And also within the conclusion, we'll also mention the practical solutions and other recommendations after the study. So in short, we say generative artificial intelligence, which is shortened Gen AI throughout this document. It's changing everything, especially in the areas of creative art and design. So tools such as ChatGPT, DeepSeek, Resleaf, NewArc, and Midjourney are increasingly becoming important. To mention, we are saying ChatGPT, DeepSeek, Resleaf, they are the popular ones which can do all the other functionalities, whereby anyone in any field can utilize these. But then we've got those which are now fashion design specific, such as NewArc AI and Raspberry AI. So we are saying these other which are fashion design specific, they've got different expectations and needs from the students, but the same expectations can also be accomplished through the other platforms, though they differ in terms of the output that you can get. Then as of late, recently, we've got our own AI platform, which is developing, I think we can say it's still under beta testing. It's called Afrofusion, which is found under ChatGPT. But most of the designs or most of the output, you would find that it is still West African, or we can say it's much more inspired by the Nigerian designs when you talk about fashion. So we are saying it's a developing area whereby somebody has seen an idea to say, how can we also try to develop AI development in fashion design in in the African sense? Because all these large language models, the LLM, we are saying they are taught. So how do we teach them? We are saying somebody.
It's not working. I'm using my laptop.
Okay. Somebody in Nigeria, they've decided to input their data so that whoever wants to design something, if you type the Yoruba dress or the Yoruba wedding dress, you'd find that even the kente from Ghana is already there. So we are saying it's a recent development that we say it's also an effort So generally, in the African higher education context, there is limited infrastructure and also the challenges of digital accessibility. Which tools can we use? The hardware, the software, etc., etc. So the gap which I identified in this study is on how many studies are examining how generative AI in fashion design, especially in the Zimbabwean context, which is in the global South context, being used or interpreted. The methodology was simply a mixed methods, where we had qualitative part and the quantitative part. The participants were 127 fashion design students, whom we selected using the stratified random sampling, and 8 lecturers and ICT support staff. These were purposefully sampled based on their experience and also on the modules or the courses which they teach at the institution. Then the data collection, we use surveys for the students and also semi-structured interviews and focus group discussions, and also analysis of the AI-assisted student projects. Then the analysis, it involved a quantitative correlation and thematic analysis, quantitative correlations for the quantitative part, and then the thematic analysis for the qualitative aspects. So we go to the results. I'm trying to rush through the time. I wanted to explain maybe on the focus group in the projects, but I think we'll come back to that point if our time is on our side. So we would find that on the results, the quantitative aspects, 80% of the students did mention that they had used at least one generative AI tool, and 100% of the lecturers, they'd say they had used some form of generative AI tool. But here is one point that I need to make clear here. You would find that from the lecturer side, the generative AI tools, they varied, not specifically being in the design sector. Some of them, they were for academic writing. Some of them, they were for other things, right? Then on the 80% of the students, there was another question on the percentage of those who had said they had not use the generative AI. You'd find that due to the instructions from the instructors to say, do not use AI in your writing, do not use AI in your creative work. Try to think as much as you can on your own. Some of them, they would mention that I fear using AI because of the issues to say I've copied from somewhere. So the students are not sure, can I use the AI or not for that particular 20%. Then the perceptions, the majority of the students, they rated the AI tools as very useful for creativity and ideation. But one point which was coming out clear was that they would prefer to do their illustrations or samples using the free tier or the non-payment schemes, whereby they are not expected to pay any money to use that particular platform. In the case where they would be given trials, let's say per day, students would even say, I can do one today or my opportunities for the day. If they're exhausted, I'll go on to the other one the following day. So that at least there are no problems, which in other ways is more of like the trial versions. Then on the correlations, there's a strong correlation between the year of study and the frequency of the use of the AI platforms, because the final year students, they will be doing projects like the Chairperson projects in fashion design, and also they will be doing their dissertations at that particular time. So you'd find the usage is higher as the year of study goes up higher. Then from the qualitative data, we're saying there was enhanced creativity and visualizations. Okay, thank you. And also limited access to infrastructure and AI tools, shifting dynamics between the traditional skills. And also there was an issue of sustainability awareness. Like if you use the platform on Raspberry AI and Newark AI, most of the students, they could say when they give a prompt, the platform can give them ideas on how to make their work much conform to the sustainability principles or aspects. But these are the area specific, the Raspberry AI and the Newark AI. Such opportunities, they couldn't get them when they use the ChatGPT or the DeepSeek. Discussion and the conclusion. One of the key insights is that generative AI is a powerful enabler of creativity and sustainability in fashion design education. But there's an issue where we say over-reliance can result in weaknesses like how can you do the manual technical skills, like let's say pattern drafting or pattern or fashion illustration. In terms of the pedagogical implication, there is a requirement which came out from the focus discussion to say there is need for a careful scaffolding of the ideas from the beginning when the students they start their first year up to the finishing, where there is need for a clear scaffolding structure, so that at least AI should not like compete with the staff member or compete with the lecturer or compete with the student, but rather try to complement the skills which are inherent in the student. Then on the policy implication, there is need for urgent institutional guidelines or frameworks that also guide students on responsible use of AI in education. In terms of the social value, we are saying in the cases of like Zimbabwe, which is the typical case here in question, the resources are limited, both for the students and the institutions. We are saying AI can offer other provisions so that at least things can be done in a much more efficient manner. And in terms of the contribution, the study, it seeks to fill the gap by examining generative AI in fashion design education, such that it provides actionable recommendations for educators, curriculum developers, and policymakers. These are the references for the study. Thank you very much.
Okay, thank you very much, Walter, for that interesting presentation. So any questions from members? Questions?
Hello, good afternoon.
Yes, please.
Please, can I be heard?
Yes, please, loud and clear.
Okay, my name is Phyllis Mensah. So thank you very much, Walter, for the presentation. I wanted to find out if this study sits on any theory. If it does, what kind of theory, and does it have any influence on the concepts? Thank you.
Thank you. Can I respond to that one?
What I think she was drawing your attention to if your study is based on any theory.
Yes. Like I mentioned, using the Lazar 2018 design thinking process. In such studies where it is practice-based, it's a deliberate ploy to ignore certain theories which might be out of touch. I would have said you could talk about the technology acceptance model, the UTAUT 2, the Universal Technology of Acceptance Model 2, according to Venkatesh 2012. But such theories, you would find that in terms of, I would have wanted to maybe share the illustrations coming from the prompts from the students and also the staff members. But I think due to the time, I would just say, in terms of the theory, I would say the design process, which I discussed before, is the one which takes into account all the other factors, whereby we are saying, how do students interpret or use technology in the way they respond to the assignments or to the tasks which they are given, which also talks about the behavioral intent and also the perceived benefits from using such technologies. But it's embedded within the design process, which I explained, though I could not go to the nitty-gritties of explaining how then the technology acceptance model and the universal technology acceptance model, the unified one, can be integrated in terms of how the students use such technologies in terms of the generative AI platforms and the benefits, and also how they find them useful. That is the technology that is the theory that can be explained under the design process, which I explained. But that part of the document is in the final document which I prepared. But it's embedded within the design process to say the theory, it informs the design process, which is ultimately, which I showed in the illustration. Thank you. I don't know if I'm answering you very well, ma'am.
Yes, sir. I think I'm clear now. Thank you.
All right. Thank you. Any other question? Okay. So I just have two questions. AI in design process, the issue of privacy and copyright comes in. So when the students use it in their work, the copyright, does it go to the students or the AI? And then the second one has to do with creativity of the students. With the use of AI, does it increase the student creativity or rather decrease their creativity? Because we're always looking at originality of whatever it is that you do.
Okay. Okay, can I respond, sir? Right.
Yes, please.
Yeah, okay, thank you. On the first question, on the copyright, you would find that one of the delicate issues, which is still topical, even up to now, which some courts in the UK are failing to address, is if I use a platform to generate a design or an idea, who owns the particular design? Because the institutions themselves, they might not have a clear AI policy, because from the institution itself, we are saying if there is an AI policy to say, declare that you have used this platform. So if I declare, I can just declare that I've used DeepSeek, I've used DALL-E AI, I have used Midjourney. But then in terms of declaring now the copyright, it's up to me as the student to say, no, I only used it to get an idea, but not. So some would argue to say, just like if I talk to you, if I ask you the colors that I can use on my shirt and you suggest use green and yellow, you are only suggesting, you are not saying I should use them. So in terms of ownership, in the terms of the copyright, we are saying it's the students or the creators of the particular output who are saying I own this. But the arguments coming from the law side are saying that, no, you are borrowing the ideas from somewhere. So there should be a co-creation whereby you acknowledge, even if you're going to establish, let's say, a design patent. But then I think these are issues which can be debated on and on, depending from which country are we coming from or from which perspective. So I would say, in terms of the copyright, I would say if somebody declares, let's say it's a student assignment, if they do declare that I've used A, B, C, D, E, to what extent, that's fine, that's acceptable. But then if the particular product goes on to be patented, there now comes another issue, because at the national level, we are saying at ARIPO, which is the one for Africa, African Regional Intellectual Property Organization, do we have a statute which guides on the usage of AI? Can I declare that I use ChatGPT to create this particular product, which is my industrial design, which is my fashion design? So I think it would then differ in the case of from which country or from which perspective are we taking from. Then on the next one, on the one which we say, does it increase or reduce creativity? I would say, for the lazy students, we would say they are creative, but there is one catch here. Your output is as good as your prompt. So if you cannot create a good prompt, a good question can give you a good response. So if your question is bad, it means the output also won't be that good. So we would say there is some input from the student in coming up with the prompt, the question which they give the AI platform. So they have to be creative in generating the question itself, the prompt. So when they do that part, we are saying they are also showing their creativity in challenging the AI platform. But then the output which they get, they shouldn't use it at face value. We are saying it's a starting point whereby the AI is saying, I am suggesting this. So it's now up to the student now to take the idea and say, this is an idea from the AI platform. I can then improve it by doing A, B, C, D, E. So you'd find that for the lazy student, they would simply take the AI output and they won't do anything to it. And then they would simply say, I have done my work and this is my output. But for that person who is much more creative, they would then say, this is the AI options which I've been given. There are 5. From these 5, I'm getting the ideas, I'm synthesizing them to come up with my own new creation, but just learning from what the AI platforms have suggested to me. So I would say it then goes again to the level of the student. I would say for a creative student, AI is good. It improves their creativity because it also lessens the time they would spend on the desk or on their drawing table. But for somebody who is very lazy, we can say it can bring some chaotic, some things which can be new. Somebody can say there can be some chaos in that case. But I would just say, if used properly, it can increase the creativity of the designer. If they use it properly in a way that is good.
All right. Yeah. Thank you very much for that extensive explanation. Okay, so I think we can always have a discussion later. So our next presenter We'll be talking about understanding the fashion and textile waste stream in Accra, Ghana. This will be taken by Benjamin-Gh and the co-author. Yes, Benjamin, can you make your slide presentation mode?
Okay. Can you hear me, please?
Yes, loud and clear. Yeah, thank you very much.
Yes, we can hear you.
Yeah, so he's having his presentation from the UK. Yeah, so you're welcome. And so you have 12 minutes.
Okay, so as rightly said, taking over. My name is Benjamin-Gh. I'm a second-year PhD candidate at De Montfort University, and I'm presenting on understanding the fashion and textile waste stream in Accra, Ghana. Why do I even choose Accra? I choose Accra because it being the capital of Ghana, and then the hub for second-hand trade, second-hand clothing trade. It actually attracts a lot of imports or clothes from overseas or foreign nations, and then they come in to the Kantomato market as the main hub. That is where it is being distributed, and this accumulates great waste issue. Aside it, there's also pollution and health issue as well. So the fashion and textile waste issue industry has a significant economic force across the globe, with a consumption increase driven by the fast fashion, which has spurred production over decades. And it's actually environmentally burdensome, where used textiles are imported to the global south for life extension via the business route, actually being said as the second-hand clothes trade, providing affordable clothes for different class of people, or for all class of people. This has rendered developing nations as a dump site, where Ghana, to be specific, Accra, is not exempted. This issue, in a way, persists because formal waste infrastructure is under-resourced and ill-equipped. And then, due to fast fashion, about 80 billion clothes have been produced, and it continues to rise with 2% annually. The methodology for this study, of which is a qualitative inquiry, I engaged 11 participants using the snowball sampling technique to recruit them. And then for engagement, I used the semi-structured interview to gather initial data. And data collection, I used Microsoft Teams and then WhatsApp as well to collect recordings, audio recordings, and then making notes as well. Those I couldn't record due to certain circumstances. I had to make notes. And then for the transcription, fortunately, I had a Google Pixel mobile phone device on me. I wanted to show the image. I thought my slides would have been too extensive, so I decided to not show the image. But if you can go online, you can search for Google Pixel, you see how it looks like. It has an inbuilt recording device that is able to record audio and then at the same time transcribe the audio. As long as it is in English, it can transcribe it for you. So afterwards, you download it and then you clean the information that you have by correcting whatever information that you have in the text as well. Due to diction and tones, you might not have accuracy with some pronunciation of certain words, so you do the corrections yourself manually. And then thematically, the data was analyzed using the NVivo software, which was also augmented with the AI tools to identify themes and sub-themes for the findings and the discussion. Data also was triangulated using secondary data in collaboration with the empirical findings from the study. So discussing the results. So this is the participant demographics for the 11 participants that I had. They were they spanned from lecturers, field operations, from the Environmental Protection Agency, founders from the grassroots, if I would say grassroots upcycling organizations. I also had one from the OR Foundation, and then consumers as well. So what you see here is I'm actually showing evidence of analyzing my information or the data that I had. So this is a reflective coding and thematic analysis. Reflective, it gives you the chance to code, come back, make some tweaks, and then other changes that are relevant to suit whatever themes that you are trying to develop. So codes were earlier developed, and then those codes were grouped into sub-themes. So as you see here, you could see theme under research question 1, high waste volume, and direct donation, you have volumes of textile waste. So these are some of the sub-themes that were created to encapsulate certain codes. And then I then present a final coding codes and themes. So the codes that I had here on the left and on the right, I have the sub-themes, and then the sub-themes were also grouped and then categorized into various themes that I use for my discussion. So the themes that emanated from the empirical study or the interviews that I conducted were 5. So the very first one talks about the sources of textile waste. The next has to do with the inadequate infrastructure and management practices. The third has to do with the what current practice is being used to curtail the waste issue or the discarded goods issue. The fourth has to do with the policy and regulation, and then the fifth, the systemic barriers to sustainable waste management. So across participants, they reiterated that the sources are of 2. First of all, which is more prevalent, is the secondhand imports. Okay, that is actually flooding the markets all the time. And then a study by the EM Foundation showed a distribution in 2022. So with the diagram you see there has to do with about 111,000 tons of textile goods that came in through Kantamanto. So that the actual figure, I would say I would equate it to 100%, and 63 got to Kantamanto. Okay, and then 30% of that were shipped into other markets in Ghana. So in Ghana, I would say Kumasi is 1, Takoradi is 1. I'm just mentioning the capitals that we are familiar with. And then out of the total, the 111,000 tons, 50% also were re-exported to neighboring countries like Cote d'Ivoire, Togo, Nigeria, or other places, though they were not already stated here. So I'm giving examples so we can understand clearly. So these are the percentages that actually came in and then they were distributed. At the end of it all, dispose rate is 40%. The 40% is not coming from the total 111,000 tons. But then the 40% is actually coming from the retained for resale. If you look at it, we have the Kantamanto to other markets in Ghana, re-export, and then the retailed for resale. So that the 20% that was retained for resale, 40% of that is what being disposed. And at the disposal level, 30% of the 40% is landfilled, and then 70% of the remaining is abandoned in environments. That's quite chaotic. Now, it now becomes important to now have a clear vision or idea about the textile issue itself. As we claim it is making, creating a great menace in society or in the environment. I then delve into find out what percentage together with the municipal waste in Accra, what percentage of textile is being recorded. And surprisingly, most of the literature that I found did not record specifically on textiles. They were all put together with other invisible materials as others, which is on the left, you see 10%. Okay. And then 6% in 2010 to 2015. This makes it difficult for us to actually quantify or know the real issue regarding the textile, discarded textile issue or the environmental burden that is being caused within the environment or within the country as well. But on the right side, we could see Ghana's solid waste composite, which the author actually did well to equate 1% as textile waste. Although 1% for textile waste, it is imperative to distinguish various dimensions. Various dimensions, I mean, what volume makes up second-hand clothes, what volume makes up household textiles, what volume makes up local garment production and textile factories in Ghana. So all these evidences or all these data are missing. And the absence of these ignores the growing contribution of textile waste derived by second-hand imports, fast fashion consumption, and local garment production. In the local perspective, it was realized that fabric offcuts were highly mentioned by participants, even though unsold stocks and production defects. In this case, when it comes to the weaving factories or printing factories that work with textiles, they have such common issues. Yeah. And then loosely, a participant mentioned that to sew a simple open shirt with 2 yards of fabrics, about 30% of the textile goods goes to waste as offcuts. I can't really say this is true or not because I've not really found any study to justify this. As I said, I'm discussing this, triangulating secondary with the empirical study or the empirical findings that I got. So the next theme, which has to do with inadequate infrastructure and management practices. So I found that there's absence of sorting systems, informal collection role, and then lack of recycling infrastructure. The informal collection role has to do with waste pickers, and then the waste pickers collect the discarded goods or discarded textiles, and then they do the sorting for organizations. For example, Reclaim Textile Network presented earlier, and she has started an NGO working on upcycling textiles. Now, these textiles, if either she does the collection herself or she has people she has employed, like waste pickers, to do the collection, these people collect them and then do the sorting for her before other processes could continue. Now, it becomes quite difficult because if there's a system in place that is doing proper sorting of materials, okay, maybe jeans materials should be put in one particular space, and then cotton should be put in another particular space. It becomes very difficult for sorting to be done. But here lies the case, everything is being mixed up, so sorting becomes very labor intensive. Now, community-led upcycling as resistance happens to be one of the major or current management practice that is happening in Accra as we speak. The OR Foundation is actually championing this with the Revival organization as well. And then similarly, emerging organizations such as the Accra We Day Foundation, Reclaim Textile Network, and Gamu Clothing. All these people are working hand in hand to make sure the issue of textile waste is being curtailed. Locally, managing textile waste and policy, there's no comprehensive management policy currently addressing the imports of second-hand clothes or internally generated textiles waste. A participant from the Environmental Protection Agency made mention that most textile waste is disposed of with limited regulatory oversight. Even though they are conducting a pilot initiative in the form of extended producer responsibility, they are yet to be evaluated to see how it can be incorporated in the long-term effectiveness. So we look forward for that as well. For the sake of time, I will be touching just bits of the rest of the presentation. Barriers to sustainable textile waste management. So we have the financial constraints. We have the capacity and knowledge gap. Capacity and knowledge gap. It is striking that some institutions some organizations that I interviewed, although they have this, we are practicing textile sustainability. However, there's a knowledge gap regarding their staff who have very little knowledge about what sustainability actually is. And they sometimes don't even see the need to find a different use for the textile waste instead of burning it. Why don't you burn it so that will be free of whatever you are talking about instead of you trying to find another means of, let's say, converting, either you are going to recycle or upcycle, whichever way that suits. So a participant made mention that I had instructed my staff to reserve some offcuts for a pilot project, but instead they discarded and sent them to the landfill. So it is actually a debatable issue among both the formal and informal sectors. So I think with much education, this could be curtailed. And then with the implications, there's infrastructure and technology deficiency. It's causing a lot of environmental issues, social and economic implications, creating affordable or providing affordable clothing, yet simultaneously undermine domestic textile industries and overwhelmed local textile waste management. And then with the policy aspects, as I mentioned, there is no policy actually governing textile waste management. Yeah. And there is one for plastics, which some participants were able to mention or reiterate that for that they know that there's recycling actually happening with plastics. But when it comes to textiles, they have no idea. For the limitation of the study, the empirical research involved a sample of 11 participants. To me, I think it's quite a small number. That's what I think. It's quite a small number to represent the full diversity of stakeholders within Accra's fashion and textile waste stream. Because you should go back to the demographics, you could realize that I think, only 2 consumers and a few lecturers and also a few upcyclers. They're not that much. Yeah, they're not that much. So maybe in the near future, anyone who wants to take on this study can actually look at a bigger number. The absence of quantitative and qualitative data from a broader range of participants and respondents. Yeah, so there's a limit in that one as well. The use of snowball sampling may have introduced selection bias because I used people I know. So after I'm done with you with the interview, you also recommend someone for me. So that's how the bias actually happened. And then reliance on online interview. So anyone who doesn't have reliable internet connection or internet access means the person could not be interviewed. Meanwhile, that person could have equally been a potential for a good source of data. And then lack of longitudinal data. This one, I didn't do a longitudinal study with this. It was just a short period thing that I investigated with participants. So maybe ethnographically, it could be also investigated to see the outcome. So I recommend that the government should invest in recycling infrastructure, support grassroots initiatives with fundings and training, and then they should initiate a strict policy and then make sure it is well enforced. And then informal sector should always also be integrated in the policy as well. Thank you. I welcome your question and your questions for answers.
All right. Thank you very much, Benjamin Egan. Do you have any questions from members? No. Questions, please. Okay, so I just have one question. In your study, did you come across any regulatory measures to restrict or limit the import and then the disposal of SHC in Ghana?
No, there's no policy that I came across. In fact, even as I interviewed the Environmental Protection Agency participant, he also made it clear that there's no policy directed towards the inflow. But currently, they are running a pilot study on EPR, extended producer responsibility, on local garment manufacturers or local textile people on how they should manage their waste. But for that of the imports, there's no direct policy that is addressing that.
Okay. I think that is one key area we need to look at in trying to cover that gap so that Ghana can also know the quantum of textile waste it actually generates, right, in the system. So we can
But
have
I'll
better
also
policies.
I would like to add
Okay.
that getting to know the volume of textile waste that is being generated, it is equally important to outline, because textile as it is not a one commodity. It is different variant fibers that come together to form different textiles for different purposes or and different functions. So as we have the synthetics, we have the naturals, we have the minerals or whichever, we should be able to categorize these waste to tell that which is forming the majority, because that is the only way we can actually understand the waste stream itself. Because if you make mention of textile forms 10%, for example, or 1%, what is it about with the textile that is forming the 1%? Please, I don't know if you understand my point. So we should be able to identify it by fiber share, because across the globe, it is mentioned that cotton and polyester, they have taken over. They are the majority when it comes to fiber distribution or production.
Okay. All right. Let's take a quick one from Walter before we go to the next presenter. I think we are behind time.
We have a
question.
question.
Okay, thank you very much. Okay, thank you. Thank you very much, Benjamin. I just wanted to ask, like the last statement that you mentioned on the issue of quantification of the textile waste. Your study was in Accra. Do you think it is it is easy? Because what I have seen with most African nations is there is lack of proper record keeping to say how much waste you generate, let's say in a day or in a week or like in a month. Would you think it's going to be an easy task? I'm just speaking from the African perspective, not to say it's the same in Accra, but I'm just asking for your opinion on that one.
Okay. I think everything that seems difficult has to start with a bold step. We first of all have to identify it as a problem before we now consider it into a policy, pass it as a law. Then we begin to investigate further to see how or deploy whatever law that has been passed to see how it works. If it doesn't work, then there are always amendments that are being made or adjustment made to make sure it suits the indigenous or the people that are involved. So for me, I think it is workable. Until we start, we can't really know.
Okay. All right. Yeah, we can continue the conversation. Later. Thank you very much, Benjamin.
Can I ask a question,
so we'll go to our next presenter.
Can I ask a question, please?
Okay. Yeah. Okay. Sure.
All right. So thank you for your nice presentation, Ben. From the you just mentioned that it appears there's no policy when it comes to waste, textile waste management, and what makes it even more complex is the fact that we know textiles has various types of materials. There's synthetics, and then of course they're natural. And so from this study, have you been able to come out with a kind of a framework that can inform policy on waste management in Accra and possibly Ghana? Have you been able to come out with something like that? Or
No, please. But then, it is something embark on after, because with this particular study, like I said, the title explains that I'm trying to understand the waste stream. But
the dry process techniques in surface modification from Hassan and co-authors. Okay, so I think, okay. So I think, Ben, you can stop sharing. Yes.
Oh, okay.
Yeah, Hussein, you can actually share your slide. Yes, please. Yeah, we can hear you. Can you share your slide?
Okay, I'll be sharing my slide. Is it visible?
Yes.
Okay.
Can you make it full screen, or that is?
Okay, I'll make it full screen. Yeah. Is it okay now?
Yeah, perfect. Yeah. So let's try and make it up to 10 minutes. I think we've actually run out of the time, so you have 10 minutes for the presentation. Yeah, so you can go ahead.
Yeah, sure. Thank you, and good afternoon, everyone. I'll be thanking the Mr. Chair and the whole conference organizing committee for giving me a chance to and present my work. The work we did here is actually a case study where we took 3 of the denim manufacturing factories and studied their dry surface modification techniques. So that's why our title is Towards Sustainable Denim, Evaluating Dry Process Techniques in Surface Modifications. We are 5 contributors here. We are all from Bangladesh University of Textiles, and I am Riaz Hussain, will be accompanying everyone. So the background of the studies is like we all know about denim, which is a type of fabric with twill-woven structures, which means it has 2 warp sets of yarns on the face side of the textile and 1 set of white wefts on the back side of the textile. That's why the denims usually look colorful. Usually in indigo denims, it looks blue on the face side and white in the back side. So when we take the denims and make it into any trouser or pants, it looks like this on the left picture. But it looks so plain, like not much dynamic. So we have to let it through some surface modifications. And then we get the second picture on the right-hand side. So for the surface modifications, we have to, there are usually 2 kinds of surface modification techniques, dry processes and wet processes. So when we look at the wet surface modification techniques, we see there is a huge amount of water and chemical usage, also the energy consumptions. Usually for a pair of jeans, it takes 70 liters of water and 150 grams of chemicals with 1 kilowatt hour per pair of energy consumptions. That's why there is a huge global pressure for much more eco-friendly manufacturing of such kinds of modification processes. On the other hand, there are dry surface modification techniques, which as the name implies, it does not use any water or chemicals. And it gives the effects on regional, on some areas, which is actually different from the wet surface modification techniques. But when we tried to study the dry surface modification techniques, we found out that there are some research gaps or the gaps of case studies, how the industry practices those processes. and how much sustainable those dry processes are. So we tried to study those and find out the sustainability in the industrial practices. So that's why our research objective was to investigate the industrial practices and provide some details of the techniques, tools, controlling parameters of those processes, and then analyze the sustainability indicators and evaluate how much sustainable those dry processes are. So for this, we went with a descriptive research design, where we went to some of the factories and collected the data through direct observations. We chose 3 factories on the criteria of 100% export-oriented dry process capabilities, which means they have been practicing it for a long time. And what we found was there were mainly 7 kinds of dry process techniques being used in the factories. I will be going through those processes and giving you some of the insights. So first one is hand scraping, where we actually create different patterns and texture effects, usually on some of the particular areas, maybe front and back thighs, and it can vary depending on the requirements of the buyers. So what we do is use emery paper, which are abrasive papers, and we remove the colors from the top surfaces of the textile using manual abrasion. So as a result, the top surface materials along with the dyes gets removed from the surface, and it gives a light fading effect. So this is called the hand scraping. So it's a very simple, straight way of getting an effect. And the materials are very straightforward. We use a dummy and emery paper. So it shows that we don't need any water or chemicals and no energy as well. This is how the visual appearance of the hand scraping looks like. So this is a very straightforward thing. And then we have whiskering, which is almost similar kind of thing, but it gives a different kinds of effect. Because while whiskering, we create thin, lighter colored streaks that might resemble the natural wear pattern, maybe the patterns of the crease that reveals for long time usage. So it's usually done in alongside the seams or the pockets. So it's the same way. We use emery paper and remove the color on the manual abrasion using emery paper. But for getting the sharp edged streaks, we have to use some plastic or wooden devices to make it make the streaks sharp. So those are also straightforward without any automatic machines or anything. Those are very straightforward manual techniques. We have dummy and emery paper, but the parameters actually depend on the grade of the emery paper, which is the abrasive paper, have grits on the paper, and those grits actually cause the abrasion with the textile surfaces. So there are different grades of emery paper. So if the grit number is high, it means the grit sizes per inch is actually very small. This means a finer paper, and this can give very smooth finish. So it will depend what kind of effects we are looking for. If we are looking for any smooth finish or any fading effect, or we need something very vibrant effect. So it might also depend on the those parameters. So it's also same for the scraping process. So whiskering and scraping might use different kinds of emery papers. So for both of them, there is no water or chemical or energy uses, just the manual process. Then we have grinding, where the upper surface of the textiles are grinded. So the warp yarns are actually abraded and worn out. And that's why there is white weft visible. That's why it gives the worn out looks on different desired areas. Usually it's done on hems, pocket edges, waist belt, pocket openings, and pocket plug areas. So it's a very simple, straightforward way. We can use grinding pens, or in some cases there has been roller grinding machines found in the factory usage. So the parameter actually depends on the speed of the grinding machines. Usually 150 to 183 RPMs are used. So even though there is no use of water or chemicals there are some use of energy, 8 kilowatt per hour for every 1,000 to 200 pieces of denims. So this is the effect we can see on the right hand side, the pen grinding process. Then we have manual destroys. Manual destroys, this is much more fashionable. We see all the celebrities using those kinds of distressed looks. So we have to go through some destructive processes where the textiles are actually ripped using knives. It can be knives, or it can be also pen grinder. So usually in manual processes, the knives are used. The knives are used to cut and pull out the warp yarns, leaving the weft yarns intact. So it gives a ripped look. So the materials are, as usual, the knives, or in some cases the pen grinder can be used. So if more prominent look are required, then in some cases the grinders are also used. So it also depends on the style and design of the garments. So in this case also, there is no water, no chemical, no use of energy. If not, the pen grinder or the electric grinders are used. Usually the knives are used. So then there are more advanced laser technology for same kind of effects. There are laser fading and laser destroys being found in the factory usage. So this is the same as whiskering or destroying or fading, but with the use of laser, where the hot laser beam is actually used for sublimating the dye, and that's how the dyes get burned out and gets away from the textile surface and reveals the white look. And it also depends on the power, or maybe the laser intensity of the machine. So it also depends on what we're looking for. If it's a whisker, if it's a laser intensity will differ. So if the laser intensity is much higher, then it can partially burn the denim surface and give it a worn out look, as we have seen in the destroy part. So this is called the laser destroy. In the factory, we have seen the laser fading machines using usually the Flexi HS machine. Usually one or two operators, actually one operator and another is the helper. And the parameters will depend on the time, laser wavelength for the power of the laser, and then the laser intensity, how much intense look we are looking for. Usually before the laser has been used on the textile surface, we have the textiles have to be marked on, so there is no mistakes. So it takes 5 to 7 seconds to mark, and then the whole fading or destroying process is done in 20 seconds usually. So in this case also, there is no usage of water or chemicals, unlike the traditional washing surface modification. So no water, no chemicals, and in some cases, in most of the cases, laser fading needs energy. So 12.2 kilowatt power per hour for 200 to 250 pieces per hour. So this is the maximum power it uses. This might depend on if we're looking for fading or destruction effect. So is the usual power consumption. And then there is ozone fading. This is also another kind of fading as an alternative of laser fading. In the ozone fading, it does not also use any water or chemical. It uses ozone gas to oxidize the surface dyes. So in this process, the oxygen molecules are hit with the ultraviolet rays and splitting them into the oxygen atoms. So the oxygen atoms then can bind together and make ozone. So this ozone can oxidize the surface dyes. So this is also a very good way of replacing the enzymes or pumice stone washes or hypochlorite bleaching techniques usually used in traditional processes, which usually uses a lot of huge amount of water and chemicals. So this is a very good alternative of traditional processes. The machines we have seen in the factories is Genealogia G2 machines with a capacity of 100 to 130 kg. It usually takes 16 minutes of time, and the parameters depending on the gas concentration. Those actually vary depending on what kind of effect we are looking for. If we are looking for a higher fading effect, then we have to use higher concentrations of gases, ozone gases. And this also takes 10.54 kilowatt hour of energy for every hour of productivity, usually 230 pieces per hour. So those ozone fading technology and the laser fading technology are the most advanced dry processing techniques that has been found in the industrial practices. So those are the usual most important processes we found in the factory. So we saw that those techniques do not use any chemical or water, but some of the processes can consume some energy. So we had to find out what's the energy consumption ranking is. So what we did is we took the energy consumption and the productivity, and then we calculated the energy that is required for every piece of jeans. So, and then we found out that the grinding process takes the lowest amount of energy, and then comes the ozone fading and followed by the laser fading. So grinding process is actually energy consuming, but the least of the three energy consuming processes, dry techniques. So the overall sustainability performance says that in this dry process we have investigated on those three manufacturing factories is that there is no water usage, no chemical usage, and very minimal of the minimum energy usage is 0.67 kilowatt hour, and the maximum is 4.8, which is way less than any other traditional washing processes we usually know. So as a result, we can see that the dry processing techniques are much more sustainable, especially when compared with the traditional wet wash processes. So this is the summary of the processes we have found out in the study. And this takes us to the conclusion that dry processes are comparatively more sustainable than traditional processes with no water or chemical usage and very minimal energy consumption. This also makes us realize that gives us a ranking of energy consumption of whatever processes take the energy takes energy. The most energy consuming is the laser fading, and then the ozone, and the least is the grinding processes. So this is the work we have done, and this is a very descriptive way and very cliche way of doing finding out how sustainable this process is. So then we actually thought that there are some requirements. There is some future research gap, future research ideas that can be useful for future researchers. For example, some in future studies can assess environmental sustainability quantitatively with precise data and calculations using softwares, and show how comparative analysis with other kinds of techniques. And also they can establish a sustainability mapping model for traditional and advanced surface modifications. So those are the limitations, and we're looking for further studies for quantitative and sustainability assessment, and maybe sustainability mapping models in future. So that concludes my presentation. Thank you everyone for listening. I will be open for any questions or discussions.
Can we get just one question for him?
Yeah, sure.
Any question for him?
Yeah, Hassan, thank you for your nice presentation. Yeah, the dry processes, as you rightly said, no chemicals, no water, and so they are more friendly. However, have you considered the issue of microfibers? Currently, the issue of microfiber pollution is a big deal. And so have you, by chance, come across any production of microfiber in the course of the production of this, some of this? And then the last one, does this processes have any effect on the strength of the material produced? Have you done any comparative study in that regard? Thank you.
Thank you for the question. The first question is about regarding the microfibers. Yeah, there are some concerns about the microfiber pollutions, but as we have seen in the factory, that the workers are very using masks, gloves, and boots, so the microfibers cannot affect them. Usually the microfibers can be harmful for the workers mostly because they're taking it through the respiratory system inside the human body. So there are some concerns still, but the workers, as we have seen in the factory, they are taking some cautions so that they does not affect their health. But we couldn't include any pictures in the presentation because of the privacy concerns of the businesses. And there are some concerns of microfibers regarding the laser fading technology, also the carbon dioxide emissions. In the factory, we have seen they tried their best to keep it in a very contained environment so that it does not affect the outside environment, especially for the laser fading technology. The laser fading technology has fume hoods which sucks in the carbon dioxide or microfibers that's been produced during the process. So they suck in the fumes or the microfibers and collect it as waste. So still there are some concerns about the microfiber pollutions. I think it can be studied in future research also. I didn't actually understand the
strength. I mean, compared to the chemical treatment or the wet treatment, the dry processes that you talked about, and then of course the traditional wet processes, has there been any comparative study on the effects on the strength or on the material property?
Okay. Actually, we did not come across. Actually, talks about this effect on the strength of those two processes. Actually, for example, if I give you an example, the laser fading technology or laser destruction technology, those actually in a common sense affect the strength hugely, but as it's fading or burning out the warp yarns from the textile surface and just leaving out the weft yarn, so it might affect the strength of the, in some places in an aerial basis, it might affect the strength of the textiles, especially comparing with the weight processes, which does not have such kind of like burnout things. But we did not actually come across such kind of studies. Maybe because those are two different kinds of effects. The weight surface modification techniques give some very different kinds of effects, and the dry process techniques give very different kinds of decorative styles. So those are very different kinds of things. Maybe that's why we did not come across such kind of studies. But there is still some chances maybe there can be studies about these things. Thank you for your intuitive questions.
All right, yeah, thank you very much. And I think we'll move to the next presenter, who'll be talking about assessing the effectiveness of workplace experience learning in HND fashion design TVET programs, insights from fashion design facilitators in Ghana. Do we have Mensa?
Oh.
Mensa, can you share your screen? Now, do we have Mensa?
Felix. No, he's there, but Ralph, I think we should go to the next person, please.
Okay, all right. So
hello,
proceed.
hello, Prof. Ralph.
Okay, so can you share your screen?
No, Phil said she's having issues with
So
yeah, because you have about 2 minutes left, though.
Abner, continue.
Okay.
Continue.
All right. So these are the methodology. Well, from where she left. The key findings. Well, as an entrepreneurial development. So we realized that real world learning platform, the world gives out a real world learning platform, and it gives an entrepreneurial identity development. That is based on the interviews. World is a structured practical attachment allowing students to apply and test their academic knowledge. So they do what they practice what is learned in the classroom on the field, and they get other knowledge from the field as well. And students actively construct knowledge through immersion in dynamic business environment, which aligns with Machiavelli et al. And the focus is reapplicable to the skills in the real world. Well is vital. It gets students ready to create job as well to enter the workforce. Then students develop pricing skills, client handling and product timeline management, as highlighted by Betts and et al. In their experiential industrial grounds method. However, there are some challenges during the world implementation. We have the monitoring gap, we have the monitoring constraints, and the academic industry gap. So under the monitoring gap, we have uneven monitoring. Uneven monitoring reduce opportunities to absorb into the business world. So when students go on attachments and we don't monitor them well, they are not able to grasp what the real business life is. Then these findings echoes well like Boating in Japan. So in terms of the monitoring constraints, we have insufficient resources for site visits and students because we know we are all logistically handicapped in terms of supervising students on world programs.
You have 1 minute.
And there are also misalignment between the educational goals and workplace practices because what the industry is doing is quite different from what the classroom study is doing. However, we are trying to bridge that gap as well. So in terms of that, student grape about being treated more like assistants than students. So when these are challenges that when students go on well, they are treated like the last apprentice. So they are intended to go, they are sent to do all the last apprentice duties. Meanwhile, that is not the main reason why they are there. So Ankara Algeria found that many fashion SMEs in Ghana lack the structured internship framework, which makes it difficult to embed learning goals into the daily work settings. Recommendation for enhancing well. There should be curriculum integration, that is industry academia measure, in order to bring out a quality curriculum so that at least when the students go on the field, they will be able to guide them to do what the classroom is looking for. Embed business planning and entrepreneurial reflection in world requirements. So like at every point in time, there should be an entrepreneurial skill as part of the curriculum too. There should be a structured mentorship program. So we should establish a formal mentorship program with clear learning objectives when the students are going on well. And we should recognize and incentivize organizations because most of the time the industry complain of them not gaining anything out of what the students are. The students are rather coming to drain them. So there should be something to motivate the industry as well so that they can absorb the students when it's well time. And institutional supports. Institutions should allocate resources for faculty supervisors and monitoring and develop digital tools for tracking student progress and facilitation feedback. So like KSU, for instance, there is two ways of supervising well. That is the virtual and the face-to-face. So virtual, we do online calling to check their students' appearance, whether they are on the field. Then face-to-face, we go and see and monitor what they are doing on the field. In conclusion, so WELL provides a constructivist framework for developing entrepreneurial capacity. However, the challenges in mentorship and monitoring and alignment limit its effectiveness. Therefore, we are saying that integrating the entrepreneurial aspect in the world assessment can transform internship into business incubation. And partnership between academia and industry are essential for maximizing the impact of work. Thank you. These are
all right. Yeah. All right. Yeah. Thank you very much. Can we have just one question? Any question from members? Okay, I think there's no question from members. So yeah, okay. So yeah, thank you very much, Abuna and Mensa, for your presentation. So I think we'll move ahead with the next presenter, Patience, that is from Rwanda. We'll be talking about smart fashion for health monitoring, integrating wearable technology, fashion, and machine learning for early chronic disease detection. Yeah, Patience, you can share your slides.
Yo, ukrom kwa besrao.
Abner, international conference, you are making this. Hey.
I'm sorry, yo.
Patience, are you there?
Yes, I'm going to look for my. Good afternoon.
We still cannot see your slides.
Can you see it?
Yeah, so can you make it in presentation mode?
Okay. Can you see my paper now?
Yes, please. Yeah. So you can go ahead. You have 10 minutes. Thank you.
Thank you for giving us this opportunity. I think you've already read our topic. Let me just go through. Let me start by asking a question like to say, have you ever come across a situation whereby your close relatives, friends, that you felt that these people are healthy, and then the next moment, next day, you hear that person is normal? You know, such situations actually made us to want to understand more what is happening, what is on the ground, what is it that we can do as well to save lives. So as we dig deeper in trying to understand this, we realize that chronic disease actually has a significant danger to the global. And as you can see, about 70% of global deaths are attributed to these chronic diseases. And these chronic diseases, they are just long-term health conditions. And sometimes they just go, you know, they are silent killers. People go without realizing that they have got problems like these ones. And therefore, sometimes there are late detection of disease. Chronic diseases, examples such as cardiovascular diseases, respiratory.
Patience, I think your audio is off.
Patience, are we safe?
Yeah, we don't have sound from you.
Can you hear me now?
Yes, it's much better. Yeah, you can continue.
Oh, okay. So I think I actually moved on. I was on this slide where I was explaining more on what we have realized about these chronic diseases, to say the cardiovascular system circulates oxygen and remove waste. And cardiovascular diseases are the leading global cause of death. So many people are dying with this. Even hypertension, it affects around 26% of global population. And proceeds to 90% health cases of these chronic diseases. Then we actually come up with questions. Okay, how might we then provide a real life time monitoring system? And we also know that clothing is worn by everyone. So why not harness it to monitor health? Smart textiles can be used to monitor patients' health and ensure that their comfort and well-being. So smart textiles are fabrics embedded with sensors. I think most of us, we've been talking about these smart textiles, and I'm sure we know what it all means about most of us. I was listening before, highlights that then we also have this other researcher who highlighted that wearable health science devices are becoming vital to manage these diseases, as they offer real-time monitoring and personalized care. So the problem statement is that globally, the high prevalence of chronic diseases, I've mentioned them, is well organized, is well recognized. So these long-term disease develop gradually, persist over time, and require continuous medical care and management. It needs management. Late detection can be fatal, particularly in the elderly, highlighting the need of effective monitoring. Smart textiles offer a promising solution by enabling continuous invasive health tracking. The aim is to develop smart wearable busters with Itfp-Gh biosensors and machine learning detection of hypertension, cardiovascular and respiratory diseases. And these are our specific objectives: to come up with to design a practical wearable design textile with user comfort for the elderly, to develop a non-invasive Itfp-Gh biosensor sensing system to be embedded into the textile for chronic diseases identification, to develop a machine learning algorithm to analyze sensor data for elderly people with hypertension, cardiovascular, and respiratory conditions, to evaluate the effectiveness of the smart textile in monitoring vital signs in these early disease indicators. So the methodology that we used, we actually use the design thinking approach, of which this design thinking approach, it's a human-centered approach, and then it actually utilizes qualitative research. Therefore, in the understanding phase, we actually looked at those elderly people. If we have realized that those are the most people who are attacked, you just hear the next moment this person is gone, you've seen that person, you've been together, then the next person, that person is no more. So we were working with a multidisciplinary team comprising of biomedical engineering and fashion design specialists co-developed this smart clothing product that is embedded with biosensors. And we were actually focusing with the elders at our college, Kigali College here in Rwanda. And the sample, we used a purposive sampling method where we actually, at the end of the day, managed to come up with 30 elder staff members that we were using interviews to come up with more information so that we'll be able to so that we get more information to come up with ideas, we generate ideas that will assist us to come up with this real-time monitoring. This is a preliminary paper that we are working together with my colleagues, and I'm giving over to my colleague to actually explain more on the next slides pertaining the technical part of the product, simulation products that we are working on to come up with real-time monitoring sensors that we can embed in the textile clothing that we have designed. Over to you, Patrick.
All right, thank you very much. I won't take much time.
Yeah, you have 2 minutes. Yeah, if you can do that
Yes,
for us.
it's okay. Now, like what my colleague was saying, there's need to monitor like different chronic illnesses. Like you see that everyone at any given time, there's need for monitoring these parts like hypertension, cardiovascular, or respiratory diseases. So our part was to design the sensing system. So if you see on the next slide, that's this is not new. The sensing part is not new. It has been done. Other cities try to do it, but there were limitations. If you look at the Itfp-Gh sensors, you see that they are unique in the sense that they are very small. They can be put in the fabric. They can embed, and any person cannot feel them. And by that, they are able to capture like the conditions in the body of a person without him or her feeling discomfort. Now, these sensors can be put, for example, in the males on the vest like that, in the sensor different locations, and also on the females, they can be put on the bra, and that tension on the bra can also give this information. So basically, if you look at these sensors, they use light, which is an optical source. They do not use electricity, meaning that they can be worn in any weather or even in water, they can be used. You'll see on the next slide, we'll talk about how sensors like operate. They take signals, for example, those are the ECG signals, a simulation result of ECG signals, and these are the working principle of these sensors. So you see that these sensors, they are able to capture even the smallest signal on the patient. And on the next slide, you're going to see that like there are ways which for any individual, like there's the measurement, every person is unique. So these sensors, they'll take the data from the person and it's also calibrated. So like over time, you see that with the machine learning, additionally using these sensors, they can give a profile of the person's health, and they also even are able to help doctors to remotely monitor. You know, in Africa, people only go to the hospitals when they are fully ill. So we are trying to make a gadget which can monitor remotely a patient and even help the doctors to know where the problem arises. And we look at the last slide. We are looking that machine learning is a developing field right now. And for us, we are using logistic regression. And by this, we can also put the other data. We can also put other data of a person, which is the age, and also the biomass index. For example, sensor systems which are there, they only take the information at that moment, but for medical purposes, they also need to know a person's age, sex, and also this can be put in the machine learning to help diagnosis. And we look at the last slide. All right, so basically, the difference is traditionally people can just sense things, but now with the advances of machine learning, a person's profile, data, even family history can also be put as the data in the algorithm, and this helps to make a device which is worn at the same time sense data correctly, and this can also send data remotely. We are still working on this, and right now we are on the simulation stage, and this is what our research is all about. Thank you.
Yeah, all right. Yeah, thank you very much. That was very quick. Do you have any question for them?
There's a question for you.
Okay, thank you very much for your nice presentation. In fact, it's forward-looking, considering the fact that you want to integrate machine learning models into your design. Quite interesting. I have a few questions to ask. Now, the first one, you're talking about physiological sensors, and here you mentioned about 3 or 4 of them. Are you looking at producing a fabric with a composite sensor such that the same fabric, can sense your heartbeat, can sense your diabetes rate, and then other physiological characteristics? So that is the first one. And then second part is, how do you intend to power these sensors? Are you exploring the tribal electricity, on nano generators, or you intend to use the traditional batteries as is currently being done? Thank you.
Thank you very much for the questions. Yes, initially, our intention was to monitor 4 chronic diseases. Now, but initially to not make it cumbersome, and we're focusing mainly on hypertension and ECG. But the same concept can be developed further for all the other diseases. But it will take more time. But for this part of this paper, we are focusing only on 2. Then the last question, I thank you for this question, for the powering part. Yes, it's something which we are still working on. But at the moment, we're considering using traditional batteries. But it's something which we are going to look further to see how best we can make the best design.
Okay, so thank you very much. My question is that you've talked extensively on the sensors and the ECG and then the rest, but I didn't hear the textiles aspect of your experiments. What type of textiles fibers are you going to rely on? Are you going to use synthetic fibers? Are you going to rely on natural fibers? As far as sustainability is concerned, please, can you elaborate on the type of fibers or textiles you're going to?
Hello?
Hello?
Hello, can you hear me?
Yes, please, I can hear
yes,
you.
we can.
Please, did you get a question?
Yeah, Patience, you can go ahead.
Yes.
Hello?
Yes, please, we can hear you.
Go ahead.
Okay, answering that question on what type of textile that we are going to use, we are actually looking forward to make use of bamboo with a spandex blend, because we want it to stretch so that it actually, measure accurately the heartbeat, the BP and ECG. So we are going to use typically the bamboo with spandex blends, because it's good for sweat management and it's also soft. And in terms of washability, it doesn't need much of ironing and all that. So we are also going to use a lining, which also has the same type of fabric, which is bamboo spandex. And also the padding, we are going to use a natural rubber foam, takes biodegradable alternative to PU foam. So that's what we are going to use. And those embedded sensors, we want to actually insert them in that design that we have seen in those places. We insert them there, and then they can be removed when washing, so that, that's what I can say about the fabric, the materials.
Right. Thank you very much for your insightful presentation. In your presentation, you made mention of the design thinking approach that you used. We know of the Stanford model. You all started with co-creation, prototyping and test. So I want to find out from you which of the models that you employed in the study. Thank you very much.
Patience, can we have you respond to the question? Okay, so I think there's a bit of a problem.
Oh, hello, can you hear me?
Yes, okay. Did you hear the question?
Yes. We actually use the double diamond. That's the one we use.
Okay, all right.
Okay.
Yes, where we have those 6 phases: understanding, empathize, define, ideate, prototyping, and testing. That's one we are actually following. Like I mentioned in the first place, that we actually started with the understanding phase because we are looking at, since it is a human-centered approach, because we also want to come up with a product that people really want, really need. And we realized that from what we actually gathered, people doesn't want to be known that they have those chronic diseases. Like traditionally, they used to, someone with sugar would have a bengal, and everyone sometimes would for stigma. Stigma. So we want them to have those pastors that undergarments that they can actually wear under their garments, and maybe after emergence when people now.
We've got
all right, so you can make progress there.
Thank you very much. Next.
All right, thank you very much, Patience, here for that presentation. So we can move on to the next person who'll be talking about skills, demand, and supply nexus in the clothing, textile, leather, footwear sector, a systematic literature review. Can we have you present your screen?
Yes, I will. I think it's asking for the last presenter to unshare first.
Yes, Patience, can you unshare? Yes, so you can go ahead to share your screen.
Thank you. Can you confirm if you can see my screen?
Yes, please. So if you can put it in presentation mode. Yes, that's fine. So you can start.
All right.
Can you put it in presentation mode?
Oh, my apologies. I think my screen has swapped to the other display. Okay, just please give me a minute. Okay, just a minute. I'm swapping my screens.
Patience. Hey, this is not patience. This is
Can you indicate, colleagues, if you can see the full presentation?
We'll manage. Go ahead.
I think it's fine. Yeah, you can actually go ahead, though.
All right. Okay, so thank you for the opportunity. My name is Nogwanda Biase, and I'm the presenter for this research paper, which forms part of my larger study. It is my first year of my PhD in my study, and I've conducted a systematic literature review looking at the skills, demand, and supply nexus in the clothing, textiles, leather, and footwear sector in collaboration with my supervisor in absentia, Dr. Sipombata. A brief overview I'll be covering, looking at the introduction, the literature background, the methods, findings, future studies, as well as the conclusions. The CTFL sector plays a pivotal role, especially when it comes to the global employment, as well as the economic development, particularly in the low and middle income economies. And it is one of the labor intensive sectors employing largely women in terms of the gender. So the sector's social value extends just beyond the economics because it empowers women and it also offers the opportunity for poverty reduction. In the past decade, we have seen crucial events that have taken place which have encouraged the global economic sectors to really re-examine their skills demand and supply nexus to either exploit the economic opportunities or to reduce the economic challenges that are faced by numerous sectors. Some of these crucial events that have happened is the launch of your Sustainable Development Goals in 2015. We also had the COVID-19 pandemic in 2019, as well as the fifth industrial revolution in 2015, which have really put pressure on the skills demand and supply nexus. And there is lack of systematic evidence on the skills demand and supply nexus, leaving stakeholders, which include higher education institutions, industry, as well as policymakers, with little information and guidance in terms of how to resolve such challenges. So as it stands, we are at crossroads in terms of economic as well as the social sustainability of the sector. A bit of the literature background, there seems to be conceptual confusion in the literature that when I conducted the literature background, as skills shortage, skills gap, skills mismatch are terms that seem to be used interchangeably in different studies. So this lack of conceptual clarity further complicates the diagnosis as well as the interventions that are required or needed by the sector to boost the competitiveness in the sector. So the studies have showed, especially in the engineering field where most of the studies are housed or are located in, as there's a dearth of information when it comes to the CTFL sector globally, specifically relating to the skills demand and supply nexus. And some of the research was found in engineering fields where they argue that a skills shortage or a skills insufficient, having insufficient skilled workers is underpinned by deeper skills gap within sectors. And they highlight that the skills shortages are a consequence of systemic failures in education systems which are rooted in long-term failures that already exist. For the methods for our paper, we looked at qualitative methods using systematic literature review. And as part of the inclusion and exclusion criteria, we looked at any papers that discussed innovation skills, skills transformation, curriculum development, future skills, skills demand, skills supply, or any 4IR related skills within the CTFL sector. With regards to the period of the research, we used a 10-year period from 2015 to 2025. And we looked at the databases such as Scopus, Emerald, Web of Science, as well as Google Scholar, with the exclusion of the grey literature, which caused some limitations in the findings. With regards to the data analysis, it was thematic analysis where we went through the papers that we found and analyzed them, and I will go through the findings and the codes and the themes that were identified in the papers. We adopted the Prisma flow diagram for our study, where we had a total of 981 studies initially at the identification stage between the Scopus, Emerald, Web of Science, as well as Google Scholar. Through the screening and analysis, so exclusion criteria applied at different stages. We then filtered down, and only 12 papers were included in the study for the full analysis. Looking at the findings, the papers that were included in the study in terms of the publication analysis from year on year, looking from 2015 to 2025, we found that the year that had most publications was 2024. And in terms of the journals that published these papers, including the quantiles as well as the impact factors, two of those were found in the Research Journal of Textile and Apparel. We also looked at two academic papers from the Higher Education Skills and Work-Based Learning Journal, and one paper each on the rest of the journals that included Journal of Fashion Marketing and Management, as well as International Journal of Manpower, just to name a few. With the quantile ranging from, some of them did not have an indication of the quantile, some of them had Q1, others had Q2, and impact factors ranging from 2.2 to 9.5. With regards to the continental analysis of these papers, we found that Asia has got a large concentration of this research, which is not surprising because they have been leading in terms of the CTFL sector development as well as the competitiveness, with Africa following right behind them in terms of the number of papers that were found and included in the study. On to the categories as well as the themes that were found. These papers included conversations on education and curriculum, where it looked at the offering of higher education institutions not meeting the demands of the sector with these misalignments, also looking at the digital and technical skills gaps that exist or the low level of adoption of these skills, as well as the policy insights, including looking at the fragmentation that exists and outdated labor policies within our sectors, as well as the misalignment in terms of the national strategies when it comes to 4IR implementation, as well as 4IR adoption. As well as on the sustainability front, there is an increase in graduate unemployment, and also there are fears of job displacement due to automation, as well as the socio-economic implications, where some studies found that there is still not equity when it comes to gender roles in terms of management, etc. Looking at the future studies and some of the recommendations that came through from our analysis and our studies. So education reform becomes quite critical, where we need to look at co-designing curriculum with industry to make sure that we've got responsive curriculum. In terms of the policy alignments as well, looking at what are the current policies and how do they actually help to create an environment where all of the stakeholders are able to collaborate, firstly, and secondly, how does the policy actually enable in terms of competitiveness? We have seen policy where in terms of imports, implementation, in terms of we've seen quotas in place. However, there is not much policy around to skills training between the sector. Sectoral collaboration becomes very important, where we ensure that there's stronger linkages between higher education, the government, as well as industry, as well as ensuring that we are building in terms of 4IR capabilities and digital readiness, where we are upskilling workers and limiting, as some of the studies found, that a lot of the countries are actually getting experts from different countries coming into the country, which also limits opportunities for the citizens of those countries. There also has to be labor market intelligence when we are looking at tools, how to actually measure and evaluate what are the outcomes of the training and the interventions that have been put about by governments within the sector. And we need to be able to measure and evaluate all of those interventions, as well as put in place measurement tools to be able to track the graduates that are coming out of the universities, your higher education institutions, going into industry, their performance in terms of where they are. Is it a misalignment? Are there mismatches, or are there skills gap? Are they having the graduate competencies that are required by the industry to fulfill the demand or the job requirements. So for the ecosystem to be well coordinated, there has to largely be alignment between education to ensure that we are fulfilling and meeting the future skills needs, which includes your 4IR readiness and your digital skills, as well as ensuring that there is preparedness for the workforce and in equipping them with the required or the necessary skills. And that goes hand in hand with the engagement as highlighted to be able to identify firstly if it is a skills gap, a skills mismatch, or a skills misalignment. And that helps in shaping the policies which will enable an environment that will be conducive for all of the stakeholders. And this will help us in order to achieve sustainability and foster long-term economic as well as environmental balance within the CTFL sector ecosystem. Thank you very much. That is the end of my presentation. I will take questions.
All right. Yeah. Thank you very much for having your presentation within time. Can we have questions from members?
I think it's straightforward. And since she's beginning, she's in the first year, we would want to see progress in the next year's conference. So I think we could allow her to move on. Thank you very much. What's the name? Is it Baesa or Baesi?
No, it's Nokwanda Biase.
Biase. All right. So next year
Yes.
we want to see progress of this work since it's still a kind of a building up. I hope we will see you feature in our next conference.
Thank you so much.
Yeah,
Definitely, I
yeah.
will be there.
Thank you very much. So I think we are good. Next presenter.
Okay, so we go to the next presenter. We will be presenting on contributions and real-world challenges of fashion and textile graduates, a case of Accra Technical University. This from Catherine Edu.
Okay. Now I'm giving you 5 minutes. 5 minutes. 5 minutes. Please, presentation mode. You talked about the topic, you tell us about why you did it, you go to methodology, you tell us a bit about the findings, conclude, then we go.
Hello, good afternoon. My name is Hawa, and I'm presenting on the adoption of zero waste concepts, technology, and a case study of small-scale garment producers in the Kumasi metropolis.
Presentation mode, please.
Okay. So fashion industry wastes 15 to 20% of fabrics in production, and
how are we?
Yes. Okay. So zero waste pattern cutting seeks to eliminate, reduce waste at the design stage, according to Townsend and Mills 2013. Techniques include subtraction, cutting, tessellation, modular systems, and APOC by Isimiaki 2019. In Ghana, small-scale producers dominate but rely on traditional cutting methods. Adoption of zero-waste pattern cutting remains minimal despite growing global awareness of sustainability. The research objectives are assessing strategies and best practices that could be applied in the processes, and also to determine the adoption extent of the zero waste pattern cutting in the industry, and how to adopt the 3 R's gearing towards zero waste process. Okay, so with my topic, these are the methodologies that I used. There was investigation of the adoption of zero waste pattern technology among the garment producers in Kumasi. We also explored the awareness and application of the zero waste pattern technology concept. Data collection method that I used was interviews and surveys, and it was mixed method as well, quantitative and qualitative. And the focus was on the application of the 3 R's to achieve the zero waste concept. So these are some of the pictures of the interviews and the qualitative, other qualitative, yes. And this is the conceptual. Let's move on to the conceptual because of time. This is the conceptual framework that I applied to achieve the concept. So in this process, we first used the pattern cutting method to cut the garment or the pattern out, and then at the end of the day, we also developed the pieces that we got into accessories, and then finally the waste that came up was also used. The third picture, which is figure 7, is showing the process, the awareness that I had, and then the process of using the leftover, the pieces, to come up with other things. Okay, so so these are the findings. I realized that there are high awareness based on the research, but there is low practical adoption because of one or two things. Because it's rigid, it's constrained you as to style. Since when you look at the demographic where I did the research, you realize that most people want styles, want to use fabric to come up with something that will fit figure types, and the awareness is there, but the adoption to be able to come up with styles and all that was limited. They also realized that they didn't know what to do with the pieces of fabrics and all that, and it was just piled up in bags. Because of time, I can't show all these pictures, but in my final works, all those tied bags are shown in the pictures. And then also because of lack of training with the technology, IT and all that, looking at the size or where I did the research, it's just the small scale industry, not the main industry where they use the card and all that. So after the research, I came up with a finding that they are ready to really adopt the zero waste pattern cutting using card and all that if there are institutional setups and there are supports to help them do that. Yeah, so looking at it, we have at the demographics, we have 38.6% of women responding to the research, and then the first one is 38.6 is males and then 61.4 females. This is as a result of the fact that we all know that they believe, or it is a perception that garment or fashion is solely for women. So more females are in the area compared to the males. Yes, so these are some of the findings of the research awareness level, and then the adoption level, and then for my results and discussion, I believe that the awareness is there, like I already said, but the practice, there is a gap between the awareness and the practice. Most people know, but they don't know what to do. So this is one finding, and then also they don't know of the benefits that could be derived at the use of the pieces, or the using of the 3 R's to reduce waste. And as a result, an awareness collaboration program was organized, and I believe we can still move by giving more education and making it more visible or understandable to the small scale fashion designers in the Kumasi metropolis as my location.
Can you please conclude?
Okay.
Conclude.
And they are
Go to the conclusion. Conclude.
So okay, let me jump to final products that I got. So you see the glass, I made clothes from the main garments, and then I made bags, shoes from it, and the leftovers. This is a book that I made, and there's a tray that I made out of the pieces of fabric with some raisins, and then the coaster and other key rings and all that. And already I have orders and making money from this product. So so these are all some of the products, from kitchen to everywhere, apart from having them as accessories. So in conclusion, I would say that zero waste pattern cutting has a high awareness rate, but the adoption is still low, and the benefits recognized, but there are barriers that persist. Like I said earlier in my presentation, there is more rigidity when it comes to application of the zero waste concept. But the 3 R's are also there to help us get to the same point of zero waste. At the end of the day, you start cutting a garment and then you don't have any piece at all. Looking at the products I was able to come up with. So my recommendation is there should be a lot of capacity
building.
Thank you.
Through
targeted training
for you. It means that you have done well. All right. So have a good flight tomorrow because you are traveling. Thank you very much. Very insightful.
Thank you.
So that we have Adam. Are you ready? Adam.
Well, I'm ready, but sharing the screen is a problem for me. So I'm trying still. Let me try again.
Isa, can you present? So, Adam, we'll postpone you to tomorrow. Are you okay?
Okay, Prof. I'm trying to see when I'll be able to.
Jacqueline, Dr. Jacqueline, are you there?
Most people have left.
Dr. Jacqueline, are you there? Are you online? Or go? It's a 5 minutes. Start present. Jackie. Oh, okay. Jacqueline, please present your work.
Please, can you see the screen?
Presentation mode. 5 minutes. I'm giving you 5 minutes. Just tell us a bit about why you, and then you go to methodology, few findings, conclusion. Go ahead.
All right. So this study explores the creative abilities of university students in a collaborative design project for sustainable fashion.
Dr. Ogo.
Yes, Prof.
Please, go ahead.
Okay. So, sustainability in fashion design education remains a critical response to environmental and social challenge, which affect fashion industry. And fashion curriculum historically prioritize individual creativity. Issues of sustainable principles that relate to ecological integrity, resource circulation, and social equity are often neglected. And in response, sustainable fashion has emerged as both academic and industrial priority, promoting educators, researchers, and practitioners to rethink how design processes are taught. Okay. So, emphasis is placed on comprehensive understanding of the life cycle of fashion products from material sourcing to consumer disposal. And recognition has been given to eco-friendly materials. Because of this, schools of thought are saying that exposing learners to ethical products, ethical production practices, and consumer awareness is deemed necessary. And researchers have also mentioned that experiential and project-based learning enhance creativity and sustainability among students. Problem-based learning, co-design models are being encouraged here. Academic institutions are now integrating collaborative design methodologies in their curricula, and students are being engaged in experimentation, problem solving, and collaborative practices to extend their learning beyond the conventional fashion education. And despite the efforts being made, several controversies and then barriers exist. So how can collaborative learning be used to support the campaign for sustainable practices? So this study purports to explore the creative abilities of university students in collaborative design projects for sustainable fashion. And the significance is that it's going to help educators and researchers and also support the gap between theory and practice. And this is in line with SDG 12. Also, support for curriculum review and usefulness in terms of education, which is embedded in SDG 4, is equally supported in that line. And this study is backed by the social constructivist theory, and then emphasis is laid on how knowledge is built through social interaction and shared experiences. The study employed, a qualitative case study, and it focused on University of Education students, clothing and textile students to be specific. And it employed purposive and convenient sampling techniques. And 77 students participated in this study, and 3 experts in fashion were also engaged in this study.
Your findings quickly.
All right. So the study sought to find out the effectiveness of collaborative learning, and out of it, it ensured that mixed abilities and students with different backgrounds are engaged, and they were allowed to leverage their skills in designing textile products. Through brainstorming, they shared ideas and came up with different concepts and products that support sustainability. So out of this, they came up with some of these products. They organized or they searched for textile products that are not in use, and they use it to design other textile products. Out of which some of the samples are here. Pure water sachet was used to design raincoats, an umbrella, and so on. And we took, I conducted interview, and out of this, these were the teams that emerged. And so on. They realized that there were effective use of dormant waste materials, and students came up with sustainable products. And it came out that skills have been developed, and awareness of how some of these dormant sustainable products can be reused in our settings for daily use was very useful. I took expert view, and they also supported the fact that what the students presented were very innovative, and creativity was at its peak. Knowledge and skills were equally in practice for students who enrolled. And students were challenged with resources as well as time constraints, and they needed support from members, which is real because in collaborative learning, some members are likely to opt out or delay the process, which affected them. And out of this, the study found out that design thinking was at its peak as students ideate their design, and then they look at how those products can be reused in daily use, empathizing what has been produced, such that they can actually wear them. In conclusion, can say that collaborative learning enhances and fosters creativity. And since the 21st century, we are all looking at different innovative teaching techniques. Collaborative learning has proven to be one of the best. It has also supported, this study has supported personal growth of the students who participated and exposed them to entrepreneurial opportunities. Incorporating skills in collaborative learning has also been useful, and it has emphasized how sustainable items can be produced to bring out creative ideas.
Thank you.
And these are some of the things that the students showcased at the end.
Wonderful, wonderful. We'll interact with
Thank
you
you.
later. Thank you very much. Can you take off your slide? We have the last one from Isa, then we'll leave here. Isa, can you share your slide? Isa. Isa Abubakar. Okay, Isa, 5 minutes.
Hello, Prof.
Yes,
Yes.
present your
Okay.
work.
Okay, thank you very much. Okay, I'm Issa Wakare, and then I'm presenting
Can
on
you
the
put it in
impact assessment
presentation mode if you can?
of digital technology usage among SMEs in the thermal metropolis. Then the global fashion industry is practically digitalizing through CAD, CAM, and then 3D prototyping and e-commerce platforms. These tools improve productivity, customization, efficiency, and then market reach. However, in developing regions like the northern Ghana, digital adoption among small and medium-scale garment enterprises remains low and uneven. Specifically, the study investigates the awareness of digital tools, level of adoption in garment production, intentions for adoption, and then the perceived benefits and barriers to usage. Then looking at the methodology, the research approach was purely quantitative approach adopted to measure awareness, usage challenges, and the benefits of digital technologies systematically. Then the research design was descriptive and cross-sectional survey design, appropriate for capturing data from a large group at a single point. Then the population of the study was small and medium-scale garment enterprises in the thermal metropolis.
Your
And the
findings.
sample size
Your
was
findings. Move to the findings. We can't see anything. Oh. Can you project it? Okay.
Can you see?
It's better. Move on. Go to the finding, your results.
Okay, so
results and discussion.
Okay.
Okay.
Okay, so looking at the results, descriptive statistics of key variables were conducted using the SPSS, and then correlation matrix of key variables were also conducted. And then out of that, awareness recorded a mean of 3.15, median of 3.00, and then standard deviation of 0.545. Then when we come to the usage of digital technologies, it recorded a mean of 3.30 and then a median of 4.00, and then future intentions as to whether they intend to use digital technologies, all other things being equal, is recorded a mean of 4.50 and then a median of 4.0. Then the potential benefits, it recorded a mean of 4.08 and then a median of 4.00. Then challenges to adoption. Challenges recorded the lowest mean, recorded low mean of like 3.5. Though that isn't the lowest, but the mean was 3.95 and then a median of 5, which means the challenges are very high. Then the correlation matrix key study variables. It has the B values for digital technology adoption, that is the awareness of 0.435, and then the perceived benefits of 0.328, and then challenges to be negative 0.242. Then with the demographic characteristics of the respondents, gender distribution, slightly more female respondents reflecting women's dominance in the sector, and then age distribution, majority was between 21 and then 40 years, showing youth-driven participation. And then looking at the education sector, most respondents had basic to secondary education, few had tertiary qualifications. And then looking at the scale, about 62.5% of them were micro enterprises, that is those who employ between 1 to 5 workers. And then the revenue, majority earn below 5,000 Ghana cedis monthly, indicating low capital turnover. Looking at the key findings, there were high awareness of digital marketing, like digital tools such as WhatsApp, Facebook, and then Instagram, but moderate awareness of computer-aided design, that is the CAD, the computer-aided design, that is the CAM, and then low usage of advanced tools such as 3D prototyping. If we are, most of them have never even heard of them. And then the cloud-based inventory. Now, for mobile money, it was widely adopted for payments and transactions. Most of them were using mobile money. And then, as part of the research, hypotheses were tested. And then the relationship between awareness and adoption scored an standardized coefficient of 0.07, and then benefits, which was the hypothesis 2, was 0.07, and then hypothesis 3, challenges to adoption, it was 0.08.
Conclude. Conclusion.
Okay, so conclusion. Digital technology adoption among SMEs in Tamale is uneven. Widespread use of basic tools, mobile money, social media, but low uptake of advanced systems like the CAD CAM and then the 3D prototyping. Awareness and perceived benefits strongly drive adoption, while financial infrastructure and cultural barriers remain critical obstacles. Now, findings highlight the need for capacity building, subsidies, and an improved infrastructure to accelerate digital integration in the northern region.
Thank you.
Now, the study contributes new empirical evidence.
Thank you, Isa. Thank you.
Yeah.
They are clapping for you. It means you've done well. Right, so we draw the curtain here. It's been very insightful, just that the time has not been so friendly to us. Let us, Raf, your few concluding words, please, and then we close. Raf.
Yes, Prof, I'm here.
Okay, just some few words and then we call it a day. You've done very well from morning to this time. I don't know how we should even award you. Okay. So Adam will do it tomorrow. Adam, first thing tomorrow morning.
Yeah.
Right, do your presentation. Okay, fine.
Yes, I think we'll have Adam then as Clements for tomorrow session though. Yeah, so we thank all the presenters for their interesting presentation. We hope you actually submit your full papers to the journal for the special issue, which we are planning to actually publish in Fashion and Textile Review. And we hope to another day, that is in day 3. And then we are actually cordially invited to actually attend or be online as we actually listen to other presenters though. Yes, so thank you very much. And thank you also, Prof. Howard, for the sharing too.
Bless you. Please, audience, I don't know how to thank you. Thank you very much and thank you. Media men, we thank you. We are grateful for staying until the end. So, Auntie Rabra is she has been going up and down here and there, and she's still here. A very strong woman. We bless you. Okay, so that is the end. Bishop.